themselves some arbitrary number of times. So now we have 5 of them. Notice what happened there, right? I went from this to this. And it was really easy to follow what happened because the part that is not changing, well, doesn't change in notation either. And the part that did change, well, it's easy to see exactly what changed. This is a property I call continuity, where you can easily follow the evolution of an object through proof steps using our notation system. And so you might think, well, nothing about these hydras really says why the order of these children has to be important, right? Maybe I could write it like this, or maybe I could come up with an even zanier notation which talks about the hydra as if it was some sort of leveled graph. And then I can say when I cut off this head, well, it gets replicated. And well, honestly, at this point, there are so many ways to write the same hydra, so many ways to write the same transformation that if I was just looking at the thing on the right, I would have to do a lot of reverse parsing to figure out, okay, well, are these 2 different representations, 2 different orders of the children the same? Did the same transformation happen? Whereas on the first notation I had on the right, where the order of the children actually mattered, you don't have to do any of that. So the advantages of having this sort of canonical representation is that equivalent objects have immediately identifiable notations, and the same transformation applied to 2 objects produces the same transformation of the notations. This is a property I call canonicity. And it's something in the case of text notations where because they're so driven by the structure, we typically have notations that are canonical, that there is really no other way you could have notated the same object, but it gets a bit more tricky with diagrams, as we'll see later in this talk. All right, so we were trying to learn from the success of text notations, and we identified these 5 properties that we think make them successful. What might this look like for diagrammatic notations? And before I go on, I just clarify some non-goals of what we're trying to do here, right? We're not trying to describe what makes a good diagram. Rather, we're trying to describe what makes a good diagramming system. We're also not trying to prove that our diagramming system is better than other tools, mostly because we don't have one. We're just describing, in an ideal world, what sort of system would we want to have integrated with our proof assistance. And lastly, we're not trying to prove that diagrams are better than text notations or something. Of course, both can be appropriate in different circumstances, and we're just saying that it should be equally easy to use whichever one you want to use in a proof assistant. All right, so back to what might these look like for diagrammatic notations. And throughout this section, I'm going to use, so we saw these little blue smiley face diagrams before. I'm going to make slightly different ones with circles and lines instead. And we're also going to use a different notation for the same object, which is these nested boxes. And so throughout this talk, the pictures I'm going to show, we had some custom code to make these pictures. And the code is not the object of the discussion. It's just the diagram's going to serve as an illustration for the principles we want to talk about. But if you want to talk about, what sort of tools we could use to make these, or how they enable or don't different properties, we can discuss that definitely at the end of the talk. Okay, let's talk about structure-driven composition. And let's build up one of these diagrams in a structured way, right? So we start with a node with no children, so a nil is an empty list, and it looks like a circle. So I'm going to have a rule already that says the diagram of a node with no children is a circle. And the little red dashed box indicates sort of the bounding box of this diagram. All right, I have another one, so now there's 2 of them, and I put them in a list. What happened when I put them in a list? Well, the 2 bounding boxes kind of merged into one single bounding box, and those 2 diagrams got put side by side. So my second rule is that the diagram of a cons of 2 things is the horizontal append of the diagram of the first and the diagram of the second. Similarly, when I have a parent node, well, it's a smaller circle, and then when the parent node gets attached to its children, it's a vertical append. So I have my third rule there, which is the same thing as we had before, but vertically. And I would also like to be able to draw the connecting lines. So while I'm composing these diagrams, I also maintain, I compose a list of their endpoints or the centers of these little circles. And at each level where I combine them with its parents, I can just draw those lines. And so following these 3 simple rules and this compositional procedure, I can make diagrams of arbitrary depth. And this is, I think, the counterpart of structure-driven composition that we saw for text notations. Now, this is very nice, and definitely there is high reward from having these pictures, But is it really low cost? Can we come up with a language that looks, well, this is an idealized language, right? This is not something that we're actually proposing. But can a language to specify these diagrammatic notations actually be as low cost as the infix thing we saw before? Maybe, but definitely I know for sure that this is lower cost than writing this equivalent TIGZ for that diagram. All right. What do good-looking idioms mean in the context of diagrams? And so now here I'm going to explain that little box notation I had before in a bit more depth. These two are representing the same hydra. So the red boxes are the innermost children, which are the heads of the hydra, highlighted in red on the left. And the nesting structure of the boxes exactly mirrors the nesting structure of the tree. Now the thing about these boxes is that I can resize them, and their children will adapt to fill the space required. So here's another box, and then I pull it vertically, and it turns into this. And notice what happened here. These two boxes that were horizontal before, because now there's more vertical space, they can use that vertical space better by being vertically aligned. I have a video of this. Let's see if this works. I've never done a video in a talk before. Ooh. Oh well. Well, the point is just that we're resizing these boxes, and they reflow to fit the space available. Okay, well, this is pretty cool. How did we do that? And I noticed that, at each level of nesting, these nested box diagrams are actually just grids. And so maybe I'd like to be able to specify a grid layout. And the grid layout has some number of columns and rows, but specified purely in terms of relative proportions, right? 1:2:1. There are no absolute dimensions here. And some gap and some padding at the edges and between the cells. And then when I finally give this grid an actual size, like 200 by 200, it draws itself to produce the picture you see below. If I give it a different size, it draws a different picture. Then I can add items to the grid. I can say there's an item that starts in the middle top cell and extends one cell to the right, and I draw that thing again, and I get this. And I can tell the grid to transpose itself, which means to treat rows as columns and vice versa, and I can draw the transpose. And so if I compose these at every level, and if I make smart decisions about transposing, where if there's more vertical space you transpose or you don't, depending on the number of columns and so on and so forth, and I divide the children into these grid cells based on how much space they will take up, well, purely compositionally, I can make these sorts of pictures with the box diagrams that I saw before. So to summarize, the idioms here that we used for the box diagrams were grid layouts and the ability to do transpositions and smart transpositions in layout of children. And the idioms we saw for the trees were, horizontal and vertical juxtaposition, computing bounding boxes and connectors and lines recursively, and being able to nest diagrams with the same interface inside each other. And these are not new idioms. Many diagramming libraries have them. We're just saying that it still makes sense for these common diagrammatic concepts to be available to the user or to the person who's defining diagrammatic notations. Continuity is easy to see with these trees, I think. So we'll do the same thing we did before, where Hercules chops off a head, the rest of it is affected, and it duplicates itself. And that was really easy to see, right? Nothing that didn't change moved on the screen, and the things that did change, well, it was easy to see what happened. But it's kind of a trick, because if I didn't align it so well, it would kind of move around, right? It takes more space. Maybe I'd run out of horizontal space on my screen. So another way I could have done continuity is with these nested boxes, because they always take up the space I told them to take up. So if I go to the next step, it didn't change size, but it did change the internal alignment of the children. So in one way, it's more easy to follow, but in another way, it's not. So different notation systems can have different continuity properties, and I think it's the job of the diagrammatic notation system to enable you to write notations that actually do give you the continuity properties you want. Lastly, canonicity. With the trees, there's one possible diagram per hydra, right? We're considering the one on the left and the one below it to actually be different hydra diagrams. And so the children are ordered both in the syntax of how you define these hydra and also visually in how they're drawn. But with the boxes, it's not so clear. There's multiple possible ways, multiple possible arrangements of children per hydra, and no clear relationship between the syntactic and visual order. All right, so what have we seen here? We've seen that we started with the idea that we definitely need diagrammatic notations in computer-assisted proofs, but they are mostly missing. And to answer the question of why, we looked at text notations or macros, and we identified 5 properties that we think make them successful. And we translated them to diagrammatic notations and saw some examples of what that would look like using our 2 domains for diagrams. Our plan going forward is, things that we have not done and we would really like to do is first to study diagram language design. There's a lot of related work where people have come up with many different ways to write down diagrams and have be generated. So one big domain is for graphs, both the mathematical and the statistical kind, and also languages for notating individual diagrams rather than having notation systems has seen a lot of work already. We also want to study diagram workflows. When you actually work with these in a proof assistant, how does that look like? Can you interact with the diagrams? Can you use them as input? Are they, do they change with things you do to them? Can you write the proof purely by interacting with the diagram? And also on the technical side, what is the best way to integrate with Theorem Prover? And we want to study diagrammatic calculi. So people have been coming up with ways to reason about mathematical domains purely in terms of diagrams and diagrammatic transformations. And I think it would be interesting to really deep dive into one of these and see whether the use or whether having diagrammatic notations available in a proof assistant and how can help that mathematician or computer scientist working in that domain. And lastly, we want to build stuff. All right, thank you. Any questions?
Thank you so much. We have our first question.
Amazing talk. Sorry, too loud. So yeah, as someone in a research group that works on a diagram text notation or diagram notation tool that is integrated into a theorem proving tool, this is incredibly fascinating. We've been thinking a lot about the continuity question that you bring up lately, and the way that we were initially trying to approach it was you have 2 descriptions of a diagram. And then you're trying to find the diff between them, both in terms of either in terms of the semantic description of the object you're trying to display, or in terms of the visual or some connection between them. But another way that you could look at it is you could think of, I have one initial diagram, and then I have an operation that I'm applying to produce the next one, right? This would be like if you're doing reductions in a proof or some other sort of valid proof operation in a proof assistant. You're trying to follow the steps, is what you were saying for continuity. I guess, do you have any intuition or initial thoughts about which of those approaches might be more fruitful to try to get better visual continuity, or some trade-offs between those 2 approaches?
Yeah, great question. And I think this is the first thing you realize when you actually start drawing diagrams, even on a whiteboard, is, well, I keep having to redraw them to make space for what I haven't seen yet, right? So one thing we thought of was, if you have actually finished your proof and you're just replaying it, maybe you can use your knowledge about what the final state of the proof is supposed to look like to draw intermediate steps, leaving space in a sense for what is yet to come. Or this could be a heuristic where you don't know what the final state is, but you just leave space anyway, just guess what you might need to draw. And the last thing we thought about is we have many powerful UI libraries for doing animation of this sort, where between 2 steps it doesn't have to be jumpy. It can be smooth, and all that matters is that the user is able to follow what happened, even though visually they might end up in different locations. So there's plenty of directions to play with in that, yeah.
Thank you. So, cool talk. It is a Herculean effort to build a general purpose library for all diagrams. Is Josh in the room? Yeah, talk to Josh if you really want to do that. So what I'm wondering is, if we restrict ourselves to the domain of diagrams for computer-assisted proofs, what is it about that domain that allows us to narrow our problem and maybe more focus this discussion? Or are there properties to the domain of computer-assisted proofs which allow us to make sort of stronger statements about the kinds of diagrams we want to generate, or to eliminate, I don't know, categories of diagram systems that wouldn't make as much sense for computer-assisted proofs? Does that make sense?
Yeah, and so I think one way in which computer-assisted proofs are really different is this strong need for continuity, right? This is a domain in which you really want to do step-by-step evaluation of proofs and see how things evolve over time, which is not always the case for any diagram you draw. Often there's just, sort of the result of a long process of deciding how is the best way to present this, and you have one figure that explains everything about the statement or the theorem or something. That's one. And another one is that the objects we're dealing with often have a lot of structure internally. So I can go back to this example. These objects have a lot of structure, right? They are not arbitrary diagrams, but they're composed of parts that have a direct correspondence with even the way I would write that in Coq, for instance. And this is not always the case. So I think we can really use the structured nature of these diagrams. And even the layout has a lot of rigidity, I think, that these things are laid out in a line as much as possible. And if they're not, well, there's things we prefer about where the arrows go and where the annotations go that are not the same for a general diagram.
Yeah. Okay, thanks.
Cool talk. I guess I had a question about whether you've thought about how the user, I guess, plays into this. Because my experience with this is, even in what you were doing, you're thinking about what's useful to you in your domain, right? And you kind of want those inputs from the user that say, I want a circle to be like the head of my hydra or whatever. And I guess, like, how are you? And the main problem I see in, I don't know, like, how do you see, like, the user integrating themselves with this kind of diagrammatic like assistant?
Great question, and I think the workflow is actually a really hard question about that we haven't thought about too much in this work. But think about how text notations work, right? The way the workflow for a text notation is that I'm doing a proof. I realize I'm writing something too often, or that I have a way of writing it on paper that isn't being reflected in my proof state. So I come up with I write a line that says notation blah. And then from that point on, it just works. And both in my input and my output in Coq, I see that notation. So maybe what we can strive for is for diagrammatic notations to be just as easy, where you notice something, even when you're just working by yourself, you're not necessarily trying to present this to someone, but it's that level of ease to just say, well, the diagram for X is such and such, and then from that point on, you use that for your own work.
And I guess I had like a follow-up on this, because I did something with visualizing a proof, and the one thing we saw was that when you're dealing with proofs, you already have your proof script and you have your like goal kind of state, and then you add a diagram to it, and you're adding kind of like another component, and as that diagram gets bigger, it's taking up more space. And have you, I guess, thought about like where it fits in, whether it's going to like replace your textual goal or
yeah, and so maybe we can look at an example where, so for example, we had one way to do a good integration of geometrical diagrams would be to replace the goal here with, well, I don't know what sum is, but, Cong is congruence, right? And so it says that the triangle STU is congruent to CBD. And maybe one way to integrate that would be to, in fact, draw a little picture that says STU and then a squiggly line that says congruence in triangle CBD. Maybe we don't do that for every single hypothesis, only for the goal. Or maybe it's up to you to choose which ones you want to see at any given time, depending on what are relevant to you. But I think it doesn't have to be, I think we should try for it to not be too much heavier than how text notations integrate into a proof assistant.
Okay, thank you.
So, yeah, in the context exactly of proof assistance, one step can sort of correspond to a lot of different actions, and getting the continuity between the two diagrams is helpful, but when there's so much sort of changing, it can then become hard to track things, and like writing, but also reading proofs. And so, do you have any idea of how we might be able to use diagrams to break things up into smaller pieces?
So I
I-
guess, yeah, sorry.
So maybe a more concrete example is, you're using these diagrams to create some abstract notation that then is easier, hopefully, to read. But if you're coming to a proof and reading it, and you might not know that notation, how might you then show that user sort of the intermediate steps, and then once they understand that, they can abstract over it and use the original notation? Did that help?
Yeah, if I understand your question, are you saying that how do you introduce someone who is not familiar with the diagrammatic notation you just invented to what it means?
Yeah, sure.
Yeah, it's a good question. I don't have very many ideas. But hopefully the diagram makes it easier. So at least it's going to be an improvement over not having the diagrams, right? If you
Sure.
just had the textual term like this, it's impossible. And if you had the diagram, maybe at least you start to get an intuition. But beyond that, I don't know. Maybe there is more work required. Yeah.
Okay, thank you so much. I think we need to move on to our next talk. Okay, our next speaker will be Tyler Holloway, who will be talking to us remotely. So I believe it is all ready. Once we switch to the slides, we'll be able to see the slides. Tyler, can you hear me? Yes, but it's very quiet. Can you say something again?
Can you hear me now?
Much better. Okay, thank you. Okay, and we're still working on getting your slides. Oh, sorry?
I was gonna say, can you also see me?
Not yet. We're working on it, I think.
Okay, sounds good.
I think we have to get our projector pointing at the right stream here. Could we maybe go one notch louder with the remote audio? Is that good for people in the back? I don't know. Tyler, can you say something one more time?
Hello?
Okay, good. You good? Yeah. Okay, we're still working on it on our end. Can you see in the room?
No, not yet.
Okay. So we have a camera here, and hopefully we'll be able to get you a stream. Okay, we can almost see your slides are in progress. Much better. Okay, now we see you and we see the slides. Are we ready to go, or are you still working on it over there?
No,
Yes, we are.
we're good to go.
Let me just check with our in-room video people. Are we good? Yes? Yes? Okay, very good. Okay, so I'm very excited to introduce Tyler Holloway, who's going to be presenting from single user to multi-user, rethinking program synthesis. So take it away.
Sure. Okay, hi everyone. Sorry I couldn't make it in person. Just a brief disclaimer, I think this paper is slightly different than some of the other things that we've presented today, so try to hear everyone's feedback, but just want to make it clear that this is going to be quite different. Okay, so from single user to user synthesis. Also, I'm Tyler Holloway. I'm a PhD student at Harvard, co-advised by Lena Glassman and Ada Amith. Okay, cool. So program synthesis, the task of automatically generating a program that satisfies a high-level specification, has been an active area of research since the inception of artificial intelligence. This field has applications ranging from biological discovery, code generation, to program repair. However, despite its broad utility and years of active research, existing systems predominantly focus on single-user interactions. While these single-user systems have their merits, they overlook a crucial aspect. Software development is often a collaborative team effort.
Sorry, Tyler, one moment. Sorry, we have to fix something here. Okay, sorry, proceed.
Okay, no problem. Okay, so single user tools have their merits, but software development is often a team effort. So software engineering typically requires a collaborative effort. In fact, a team typically comprises several roles, including software developers, quality assurance engineers, and project managers, as highlighted by research from Whitefield et al. The value of collaborative practices has even been supported by empirical evidence. Studies such as those conducted by Binker and Korkala indicate that collaboration positively influences aspects like communication, creativity, and ultimately the quality of software. However, limited work has been done on the application of program synthesis in team-based settings, where these tools may present a unique set of challenges and advantages. Furthermore, existing studies have yet to fully explore the nuances of how teams use and interact with program synthesis tools to complete tasks. We hypothesize that this disconnect between tool design and the collaborative nature of software development creates a gap in the effective application of program synthesis tools within team environments. We also hypothesize that addressing this gap could result in the development of more effective, team-friendly program synthesis tools, potentially improving the robustness and corner case handling abilities of synthesized programs. This is particularly pertinent as recent studies suggest that individual users grapple with providing comprehensive specifications, including input-output pairs. Cool. So in this presentation, well, to explore this potential gap, we propose 2 study designs with 3 primary objectives, which I will go over now. The first objective is to uncover the unique limitations and challenges that teams encounter when using these tools, compared to individual developers or end users. The second objective is to identify any emergent best practices or strategies that teams employ when collectively generating specifications to describe the desired program behavior. And finally, the third objective is to examine the techniques that teams employ for collectively evaluating and iterating on the synthesized programs, or the candidate programs. Okay, so jumping into the first study design. This is a between subject study. The study will involve a total of 24 participants to be recruited from university computer science departments. The sample will be diverse in terms of grade level, ranging from undergraduate to graduate students, and potentially from different educational institutions. How the participants will be further selected is to be determined, but it will likely be on prior experience with programming languages or certain programming languages and projects. In this study, participants will work on 2 tasks from predefined hackathon-style challenges. They will use a single user synthesizer or just a synthesizer for one task and will not have access to a synthesizer for the other task. The participants will either work in pairs or individually to complete these tasks. The aim or the goal of this is to tease out, 1, the impact of the synthesizer, as well as the impact of working in teams with a synthesizer. Just a couple notes on the style of questions. We hypothesize that choosing hackathon-style questions for the study offers a couple methodological and practical advantages. First, the time-bound nature of these tasks introduces an element of urgency that may reflect time constraints commonly found in real-world software development. Second, hackathon tasks are typically designed to be collaborative, aligning with the study's objective to examine group dynamics and interactions with the synthesizer. And finally, hackathon questions often require a blend of skills: coding, debugging, design thinking, which might enable a somewhat comprehensive evaluation of how a synthesizer can be integrated into various stages of software development. Okay, study design 2. This study will involve recruiting 4 to 5 existing software development teams or teams totaling 20 to 25 participants from various course projects. The teams will be selected based on their ongoing software development projects. In this study, rather than prescribing specific tasks, the study allows participants to work on challenges from their ongoing projects. These may include common software development tasks like bug fixing, feature addition, and code review. After an initial orientation and consent process, teams will be observed over 1 week as they tackle tasks using a synthesizer. A mid-week check-in will be scheduled to address any questions or challenges, and the study will conclude with a semi-structured exit interview conducted at the end of the week. Okay, so I'm now going to go into, I guess, some guided questions that I'd love for people to answer. I don't know if that's possible with the audio stuff, so maybe I can just briefly go through them. But the upshot is that these studies have these study designs have some limitations, and I'm going to go through a couple of that I think must be addressed before really conducting any user studies. One is, what can we glean from student projects? So in the second study design, I mentioned that we could have 4 to 5 teams, and the easiest thing would be to recruit these teams from courses at Harvard, for example. So a lot of grad courses have final projects, and they often work for about 2 to 3 months in teams of 2 to 3 to complete them. Okay, but the issue is that this demographic or these type of projects contrast sharply with professionals in long-term roles and projects. This difference could affect interactions with the program synthesis tool and limit the study's generalizability to professional settings. That being said, we recognize the benefit, yet challenges of including professional developers and early stage startups to possibly enrich the data and the feedback generalizability of this study. So that's one. What can we glean from that? Another is, what insights can we derive within 1 week time frame, or even from an hour-long laboratory study? The hour-long laboratory study is the first study design. So the second study lasts only 1 week, limiting our insights into long-term behavior until adoption. Additionally, it restricts our ability to assess the sustained impact on project quality. However, this study could still serve as a foundation for informing future and more extensive research. Sorry, that's a duplicate. Another question is, should we dictate how the synthesizer is used or observe the natural usage by the teams? Another question is, should we use a large language model to generate the candidate programs? And this is definitely something that we will have to think about quite critically. Given that large language models offer flexibility but lack formal guarantees, we believe that this could help us in discovering what types of specifications work best for different groups. And some closing thoughts are, generally the study aims to scratch the surface on 3 fronts. And actually, I kind of take this back. I think I hope to understand these 3 questions, and I think this study actually only scratches the surface on the first. So I'm really interested in this idea of group sense making in the context of program synthesis or using program synthesizers in team-based settings. So 3 things that I think have to be thought about and worked on are identifying the ideal specification types for groups, gaining some insights into how to guide the synthesis search algorithm based on group-based heuristics, and finally ranking the candidate programs based on group interest and needs, preferences. And again, I think this study would only scratch the surface on the first one. And that is it. Thank you for listening.
Testing? Okay. So we have to make sure we use the microphone for questions so Tyler can hear us. Comments? Yeah.
Thank you for the talk. I was wondering whether you could clarify a little bit on what you mean by hackathon style questions. And my question is derived mostly because if you give someone a 30-minute task, how well could it be parallelizable versus someone just doing it by itself? And if you compare a team with synthesizer and team without synthesizer, wouldn't it make sense to also have a single person with and without the synthesizer to look for the team-based dynamics? Thank you.
Yeah, sure. So I should have came with a concrete hackathon example question, because I knew this would come, or example, yeah. But to answer the second one for sure is, so in the first condition, I didn't quite make that clear, for the first site design, we are hoping to have 24 participants. 12 of them would work in pairs and 12 of them would work individually. And regardless of whether you're in a pair or a single, or whether you're working individually, you would still go through 2 conditions. One condition would be solving a hackathon style task without a synthesizer, and the second would be solving it with one. I actually did a pilot, 2 pilots over the past week where, like, instead of doing hackathon style questions, I did regular expression tasks. And it was the same two conditions. Yeah, every condition had a regular expression cheat sheet. And I think like I was starting to see some interesting things there, but I'm just concerned about giving such a narrowly scoped programming task.
Hi. Since you're joining us virtually, I'll introduce myself, Jonathan Aldrich, Carnegie Mellon University. Really interesting talk. I'm really excited to see what your results are. Since you're
Thank you.
thinking about design of the study, I was wondering what kinds of data will you gather in these studies, and how would that bear on some of the questions you're asking?
Yeah, so there's some HCI, I think it was actually from psychology. It's called critical incident analysis or the critical incident technique. And pretty much you observe people and you either have them or you identify the incidents that lead to either a failure or a success. And what you define the failure as and success is obviously dependent on the study. Here it might be a couple things. One being like whether a program was synthesized that meets everyone's preferences and needs, whether a program that is efficient in some XYZ way is generated. So I think this will change, but it would be interesting to do some type of CIT thing where we can tease out some incidents that lead to the success or failure of really single user synthesizers in team settings. Does that kind of answer the question?
Yeah, I think so. So basically, at a high level, it sounds like you're going to be observing and doing some qualitative analysis that can lead to a deeper understanding of this. That sounds really interesting. Thanks.
Yeah, exactly. Thank you. Yeah, it's quite open-ended, which makes me nervous about the study, but I'm hoping to do something open-ended to guide pretty much the rest of the research during my PhD.
Hi, I'm Will Creighton from Brown, and my question is I'm curious between the pilot studies you've done as well as related results from collaborative software development. What kind of phenomena are you expecting to see? Like, are there certain things you would expect to see happen when people build these shared specifications? Or things you'd be surprised if they didn't happen. I realize you can't go in too expecting to see stuff because that defeats the point of open and qualitative analysis. But I'm just sort of curious if you have a sense from both your pilots and the related work of like what sort of stuff you might be expecting to look for.
Yeah, I think there's definitely two things. One is how much better the specification is compared to when a single user puts it together. So I expect to see more edge cases being specified or encoded in some way. That's one thing. And I was already starting to see that in the pilot studies. One thing that I didn't see in the pilot studies, and I think this is largely because of like the task that I was given, was conflict and how that's resolved either in the specification stage or in like the ranking stage of the candidate programs. And I hope that's clear what I mean by conflict. Like there might be a case, and I honestly haven't quite seen it yet, where some some group member wants X to happen and encodes that, but another wants like Y to happen, which kind of contradicts or conflicts the first requirement X in some way. So those are two things that I'm hoping to see in some way.
Got it. Thank you.
No problem.
Great talk, thanks. I had a question based on your slide about large language models. I was curious if there's any existing work you're aware of in how using large language models interacts with code review and whether that might relate to your work or whether you're more interested in how people use the synthesizer in the first place rather than how they evaluate the output of the synthesizer.
Yeah, got it. Sorry, you said related work on language models for what? You just cut out for 1 second at the beginning.
So people, engineers or people using language models to generate code and then how they interact with the code review process. So like if you're going to be, you said you'd be interviewing teams like over the course of a week. I'd assume they'd be doing code review in that process. Is that something that you're going to be studying or are you more interested in other aspects?
Yeah, I mean, I would love, so keeping it open-ended, I wasn't going to, how can I answer this? Okay, so I assume that when we give them a synthesizer, whatever form that is, or whatever type of synthesizer that is, that they'll do a couple of programming tasks on their own without me saying that. And I assume one would be code review. I don't know if that's completely answering the question, but I wouldn't necessarily require it because I kind of just want to see what they naturally decide to do with the synthesizer. But of course, that makes the analysis so much harder. There was one other thing I was going to say though. In terms of large language models, though, one thing I've been interested in related work is like multi-agent systems and like how agents are now being kind of powered by large language models and things like that. And I think that may be a way to augment traditional program synthesis algorithms slash LLM type stuff to do multi-user program synthesis.
Awesome, thanks.
No problem. Thank you for the question.
So, oh, did you, okay. So one thing I'm curious about is the sort of the range of different teamwork situations that come up.
Yeah.
So, you know, teamwork, it ranges from people who are really working alone but with large teams, and so they're coordinating on tasks and they're agreeing on deadlines and deliverables and requirements and that sort of thing. But the actual development happens, you know, in a solitary kind of way primarily, versus sort of a pair programming or even larger scale context where people are sitting at the same computer, you know, working together on a task.
Yeah.
Which sort of situations are you focusing on, or are you looking at all of them in your study, and how do you think about that?
I think you cut out the end, but are you saying which situations am I focusing on, or am I going to just focus on all of them? Was that the end question?
Yeah, right.
Yeah, okay. So the pilots that I've been doing have mostly been like the pair programming, maybe with like 3 people instead of 2, and I don't think that's quite generalizable. So I think what I'm trying to find a medium between like a true like development like software engineering team at a company, even startup, and that by maybe focusing on student projects and seeing how they do that for a 2 to 3 month or a week span, maybe eventually a 2 to 3 month span, because that's usually the typical time to do group projects. Yeah, yeah. I mean, ideally, it would be cool to focus more on like how a real team is doing it and maybe restrict it by the domain they're working in or like the size of the team or the goals. But I think for right now, I'm going to just focus on small group projects for the kind of initial foray into this.
Okay. I think it would be interesting to think about sort of how the team contribution process or teamwork process relates to the choices. So I could see
Yeah.
sort of exploring a range of different teamwork configurations being interesting. John?
Yeah, that's very true. Yeah, yeah. I mean, that would be really nice. I think like one way I'm backing away from one way I'm like backing away from doing that is because of my fear of doing the analysis, but I think I might just have to suck that up because I think the results would be really interesting if I did that.
Do you have, I see, you stopped sharing. Are there any other topics that you're hoping that the community can help you think about?
Sorry, any other topics that I've been thinking about related to this or just in general?
Well, if you're looking, I mean, this is sort of a more open-ended discussion because it's preliminary work. So if there are sort of things that you're hoping the community will offer thoughts on, maybe you could ask us directly your questions.
Yeah, yeah. I think I guess some of my 2 main things are ideas on who to recruit. I think you kind of just touched on that. Another is like whether I would just love to know people's thoughts on using a large language model to synthesize these programs. Um, I did some pilots with a traditional synthesizer that generated regular expressions, Pythonic ones, and that didn't go quite well. So yeah, that's kind of why I'm leaning more towards LLMs at the moment.
Yeah, I thinking more about the large language model. Like I wanted to ask, I guess, a more pointed question, but I don't know. I'm trying to read the room because I don't know how everyone feels about LLMs. Like my kind of view of the situation is like I have worked with some like prototype research synthesizers in the past, and they're like really, really hard to deal with. I assume that they've gotten better like since like the last time I touched them, which was like 3 years ago. But like I use large language models all the time, like every single day to write code, and like lots and lots of people do. So I guess I'd be curious, like in choosing between using classical versus contemporary synthesizers for this study, like what would be your motivations? Because like I could see like a motivation for using LLMs is everyone uses it, so you're studying like real things that real people use. Whereas maybe your motivation for studying classical synthesizers is you're trying to make them more usable so that they can become a thing that people use. I guess I'm curious like what your motivations are there.
Yeah, I think one key motivation for using LLM is just how flexible you can be with the prompts or the specifications you provide it. And I'm hoping that that will kind of uncover what teams are most comfortable providing. Another thing is just like at least with the synthesizers that I've been working with, which are honestly pretty basic, bottom-up, top-down enumerative type synthesizers, the speed at which the candidate programs are generated and the quality of the candidate programs is just miles apart. So those are two of my main motivators.
Makes sense, thanks.
I wanted to ask a question about your longer term thoughts, and in particular, I think you mentioned that you know, in a team, people might have different ideas, right, about what they want, and those have to be resolved. I wonder if I mean, you know, I think maybe a naive way to use an existing synthesizer would be to have the team agree on, you know, the specification that they want, and then just give that to the synthesizer. But I wonder if there might be value in the synthesizer knowing about the disagreements in the team and sort of using that tension somehow to do synthesis better than it could if those were sort of prematurely resolved.
Right. Yeah, absolutely. Yeah. I think layering like consensus and conflict resolution type stuff on top of a synthesizer would be so interesting. And that was actually what I was like kind of hoping to do before jumping into this user study, but I wanted to take a step back to maybe just see what other things are coming up. Definitely a possible.
So you said you're running a between subject study. Did I understand correctly? It's people who have the synthesizer and versus people who don't. Are those the two conditions?
Yeah, so that's the first study proposal. So between subjects, yeah.
So how will you compare the results?
Actually,
I mean, you'll
sorry.
see a lot of different things.
Yeah, so the between would have so the between one that I proposed would actually have two things going on. You'd have 24 people, half of them would work in groups, pairs of two, half would work individually, and all of them would go through two conditions. They would do one task without a synthesizer and then one task with it. And I think what we would eventually want to compare is the effect of the synthesizer both on the individual and groups, and then also the impact of like working with the synthesizer or without it in a team type situation.
Okay. Okay, we have time for maybe one more question. Anything else? Okay, thank you so much. Let's give a round of applause.
Thank you for all the questions.
Okay, Katarina. Katarina has the honor of receiving our most caffeinated presentation award. There's caffeine right in the title. So this one is called Latte Lightweight Aliasing Tracking for Java.
If you want to get some water while I'm trying to present, feel free. Okay. I think this is probably the best that I have. Okay. Hi everyone, my name is Catarina Gamboa, and today I'm presenting you our ongoing work on LATE, lightweight aliasing tracking for Java. And this is a joint work between CMU, Brown, and the University of Lisbon. But before starting going into the work, I want to do a small demonstration with all of you, if you're up for it. Okay, so please use your arms to point at someone else in the room other than yourself. Everyone, please. Okay, now everyone look around and try to see who is directly pointing at you. Okay, you just came, but you can point at someone in the room. Okay, so if we look around, seeing who is directly pointing at you is not very difficult, but now try to see who is indirectly pointing at you. So who is pointing at someone that is pointing at you, the transitive relationships in our pointings. That makes it a little bit harder. You can drop your arms now. And if you're online, I'm sorry, it's even harder to figure out if someone is pointing at you. And so this small exercise just shows a little bit of aliasing. So if each of our arms is a pointer in a program, we might be aliasing other values. And so it shows how difficult it is to track aliasing. But aliasing happens everywhere, for example, in languages like Java, like we are studying in here. So if it is difficult to track it, why do we really need to do it? And our main motivation in here is software verification. So in some verification techniques, like Liquid Java, we can add refinements to the types of the language. For example, if we have an account, we can have a field that is the amount, and when we try to withdraw some value, we want to make sure that this value is smaller than the one that we have in the account. So in these verification techniques, we can then verify these values. For example, if we have an account with 500 euros, dollars, wherever, if we try to withdraw more than that value, it will give us an error. But now let's say that we don't want to withdraw only from one account, but from two accounts, A1 and A2. And we still want to make sure that we have enough money in the accounts to withdraw. The most obvious implementation would just be to withdraw from each of them. But what happens if A1 and A2 are aliases? We might be trying to withdraw more money than we should from the accounts. Therefore, to be able to track these aliasing properties and to be able to verify these programs, we need to be able to track aliasing. And so our main goal in this work is to track aliasing with precision for verification in Java. However, most approaches with this goal do not have a focus on developers. They usually focus on expressiveness and usually include a lot of concepts that lead to a complex mental model that is both difficult to understand and use. So our second goal for this work is to have a low overhead for developers, both while writing code and while understanding the errors. And with these objectives in mind, we started going through the related work. And there are some current solutions for type systems that track and restrict aliasing. One of them using uniqueness, that says that a unique variable contains the only reference to the object it holds, otherwise it contains null. Another option is using ownership, where we have object-level privacy by preventing objects from being accessed outside of their enclosing encapsulation boundaries. So when comparing these two, we see that ownership actually does not usually provide the precision that we need for automated verification, especially when compared to uniqueness, since it permits aliasing within ownership bounds and contains a lot of may-alias relationships. So with this in mind, we started going through other of the related work, and they usually fall into one of four downfalls in regards to our goal. The first one is that many approaches use specific language features that are actually not present in Java, so we actually cannot use them. For example, La Casa adds uniqueness to the Scala language using object capabilities, but they don't really have this in Java. When we think about ownership, obviously Rust comes to mind, but it also has some features that are just not present in Java, like borrow checking and immutability. There are other languages that include some move semantics, and other languages include destructive reads, where when we try to read a variable, for example, it automatically destructs it, making it difficult, for example, to query information about a unique object without losing it. And to try to come up with solutions for some of these problems, there are other approaches, like alias burying, that tries to solve the destructive reads problem. But by doing that, it also introduces other problems, like breaking common patterns and modularity, since it exposes some implementation details. Then there's a lot of other approaches that have a large and complex set of abstractions that developers need to understand. For example, even for Java, alias Java has ownership with parameterization. And then there are approaches with new languages that try to join a lot of different aspects or concepts like ownership types, linear types, and regions that are very expressive, but are not so easy to understand by developers. There are also other approaches that depend on runtime checks. For example, this work by Milano et al. Aims to have a low annotation burden, which correlates to our initial goal, but then still depends on runtime checking. So, after reviewing all of this related work, we decided to bring some more points to our initial challenges. So we still want to track aliasing with precision for verification in Java, but now we also want to make sure that many existing projects that are already in Java will still run. So we want to make no changes to the language semantics, compile existing Java programs, and so that developers don't need to relearn or change their habits, we want to support common patterns. On the side of low overhead for developers, since it has been a difficulty to make them understand what's going on in the languages, we want to have a small set of invariants that are easy to understand, a low annotation burden, and useful error messages. And with this all in our mind, we go to our approach, Latte, that tries to add unique references to Java, where no two references in the heap point to the same unique object. And then we can do this by adding some annotations to the code. So we have these three main annotations, shared, unique, and owned, that can be added to fields or parameters of methods. So the first two can be added to fields and parameters, the last one only to parameters. Shared is our unrestricted aliasing annotation, that is just the default in Java. Then we can have the unique annotation that says that a value is not referenced by another field or unique variable. And then we have the owned annotation that says that something is unique in the local context, but owned by a calling context, which is similar to borrowed in other languages. And then, aside from these annotations, we try to do alias tracking in the stack. And now to introduce some of these concepts with an example, we will see in here some parts. So on one side, we have some code to explain what we are doing, and we have also our typing environment. So if we have no annotations, we'll just say that this variable is shared, like it is happening in our field A. Then we have this field B that has the unique annotation, so we add to our typing environment the unique B. And now, when we have a method, we will see how we can do the local alias tracking in our typing environment. And to help with this, on the corner, we will also have this aliasing graph so that it's easier to understand what's going on. So starting with the signature, we have this on this. So in our context, we will also have it, and also in our aliasing graph. And then when we create a new object, it will just stay with the bottom type so that we don't know, because we don't know anything about it. And then when we say that C is equal to this.b, we will create an aliasing relationship between C and this that will be showed also in our typing environment. So this just showcases some of the concepts that we are working with. And now we are going into a slightly more complex example with a stack that has unique references. So let's say that we have this node with value and next, and both of them are unique. So when we can have a constructor of this class, we'll just say that both of the parameters need to be unique so that we can assign them without problems. And now we have our stack that has a root that also needs to be unique, and the constructor is just similar to the previous one. But now we can look at the push method and see how we can still verify that the unique references stay unique. And an implementation of this method would just be to create two nodes, assign r to this.root to null, and then create the new node with the two values and assign root to this one. Don't worry, I'll go through it slowly in a minute. So, starting with the initial part in our signature, we will have the two parameters in our typing context, the this and value, and also appearing in our aliasing graph. Then when we create r and n, they will both be with the bottom type as we saw in the previous example. And now, when we say that r is equal to this.root, we will add it as an alias in our typing environment, saying that R is an alias to this.root. After, when we say that this.root is equal to null, we can see that there is no relationship anymore. Since this.root does not have a value anymore, we can say that R is now unique. So when we try to invoke the constructor of node, we know that both value and R are unique, and so we can use them. When we assign this new value, it will also be unique, since the constructor gives us a unique node. And when we try to assign this.root to n, it will create a new aliasing relationship in here afterwards. And this is just a small explanation of what we are doing here. Since this workshop is more focused on the human aspects, I'm not going into more details. For that, we have another talk in iWaco on Tuesday, so please come to learn more about the details and the formalization that we did on featherweight Java. So going back to the initial challenges that we had, now we can track aliasing using uniqueness annotations, inference for verification in Java, for local variables and aliasing tracking in the stack. And then we accomplished to have no changes to the language semantics and compile existing Java programs using annotations in Java that are always optional and the default of the shared annotation. We can also support some common patterns by having the local aliasing inference and tracking within these local parts. For the low overhead for developers, we managed to have a small set of invariants, basically only the one that I told you before, and there is a low annotation burden. We see in here that there are 3 annotations, but one of them can even be a default, so omitted, and we have local inference and annotation defaults. But there are still some parts that we are working on. So for our ongoing challenges, still in the part of aliasing tracking, we need to investigate the expressive power of our approach to see what kind of programs we can write with this kind of approach. Also, we want to integrate it with other verification techniques. Our initial motivation for this work was indeed Liquid Java, but the idea is also that we can use this approach within other verification techniques that depend on aliasing tracking in Java. And then on the side of the low overhead for developers, the last point that we started with as one of our challenges is still not answered. Although we have tried to make some design decisions that go through the point of having better error messages, we still need to see if they are really more easy to understand. We need to investigate the usability of our approach. So our design is focused on improvements for the developers, but we still need to really see if this is what is being accomplished. And also we want to see some possible IDE integrations. And with this idea, I got some topics for discussion that I think could be interesting for this community. On the side of how we can evaluate the usability of Latte, we were thinking about using it maybe as a standalone so that it can be integrated into other verification tools, or is it better to evaluate it already into a verification tool like Liquid Java? Or is it better to compare with other techniques that already exist for aliasing? On the other hand, we have seen some popular IDE integrations that could be helpful for developers to understand better what is going on with the aliasing and the aliasing tracking. So what kind of IDE integrations would be interesting to explore? Maybe it could be helpful to visualize the type checking context, as we did in here a little bit, or have some aliasing highlighting, as we saw in other projects in the past. All of these are questions that we want to explore and also get some opinions from the community. And with this, I finish my presentation, and thank you very much. We are open for discussion.
Thank you. Questions?
Thanks for the shout out at the end. Is this approach, how do you deal with calling contexts? Is this a whole program analysis? Is it modular? You know, if a function returns a pointer that could alias one of multiple arguments, how do you know, like, where does that information of which argument it aliases get stored or tracked?
Yes, so all of this is still very ongoing. So some of those problems we are still not checking at some point. So right now, we could use some of those annotations to say that something is still unique after the invocation or not. And we are just being very restrictive in the sense that if we say that something is unique and something changes to be alias to something else and we cannot track the aliasing anymore, it just becomes shared and we cannot see anything about it. So we want to be as precise as possible, which means that we will also be conservative in the sense of things that we can give to developers. So if they are unique, we can track them. If there is some other connections that make them not unique, we will not be able to keep tracking them.
Okay, that's really interesting. So I guess a follow-on is, I think, a really interesting direction that kind of intersects between the core analysis and the human factors is about this issue of modularity. Because the way that Rust achieves this, right, is lifetimes and lifetime polymorphism specifically for functions. And which I think is interesting because on the one hand, everybody hates lifetimes. Every user finds them confusing. Nobody likes learning about them. It's the thing everyone complains about. You know, it litters your Rust source code. But at the same time, it is the thing that enables Rust to make aliasing analysis modular. And that enables the localization of errors. It enables the encapsulation of the alias analysis in a way that I haven't really seen in any other production-grade language. And so it's a very interesting trade-off. And I think one thing that would be cool to investigate here, right, is if you, basically either are there alternative mechanisms that are more lightweight for doing the analysis modularly, or if you're doing a whole program analysis, what are the human factors of that? I've never really tried programming in a language where I had a whole program analysis running the whole time, and because that also introduces issues of, you have now this global set of dependencies, and you have, what's the cognitive dimensions term? It's viscous or it's not viscous. I don't remember which one, but it's like, you have the very non-local dependencies. You change one thing over here, and it causes spooky action at a distance. Sorry, I realized this was just more of a comment than a question, but I just wanted to point out that, I think as you're thinking about this, that's really, I think this work is most interesting from a human factors perspective if you don't fix the design and then say, well, now is it usable? I think one of the core questions to really ask here, especially in the context of something like Rust, is could we get a similar mechanism that's way easier to use but has some similar modularity properties? And yeah, we should keep talking about it. I'll be curious to see what you end up resolving and where, what the limitations are and stuff like that.
Yeah, and that brings a big question about the trade-offs between expressing a lot of different things and keeping it simple for developers. And it's something that we've been trying to mix a little bit. And we still need to also see the expressivity of our approach. So maybe when we'll start doing more complex programs, we will find that, well, maybe we need to add some more aspects that we have not seen so far. Yeah. So definitely we will have to consider all those possibilities. Yep.
Yeah. Thanks. Great talk, thank you. So another maybe simpler pointer analysis that you can consider is just nullness, is the pointer null or not? And what I found in doing this in practice, trying to, because one of your goals that you expressed was that you can do this on existing code without having to go through and annotate every single thing. So you're like, oh, we can use a default. But one problem that I've found in practice when doing nullness analysis and having a default annotation is what should the default be? And the interesting thing that comes up, and so this kind of builds off some work on combining gradual typing and program analysis from before, is that you kind of want the default to be different depending on whether people have thought about your tool or not. So in particular, in code that hasn't been written before, maybe you want the default to be something that is permissive in a way. I don't know. It's if you haven't been thinking about the tool before, maybe you want the default to be, oh, it's probably could be null or not, or maybe either one, and we're gonna not always check. And then if you go through a file and you're like, okay, somebody's gone through the file and written annotations for this, now the default switches to be something that's more strict. And you kind of have this gradual migration path of maybe default is different per file or per class or something. I'm curious if you thought about this and how it relates to the human factors aspect of your work.
Yeah, we did not think about that, and since this is ongoing work, thank you for all the suggestions. Yeah, for now we just said that the default would be that all variables and fields are shared, since that's the thing that usually happens in Java when no one is caring about it. It's just everything could be shared, so we don't really care. And the idea was to, then if we want to analyze some parts, we will add unique annotations to make more precise verification on those parts. But that's certainly interesting, and we could look into it. Thank you.
Thanks.
Thank you. Cool talk. So I'm going to present another closely related work at IWACO tomorrow, or no, the day after tomorrow. So I look forward to talking to you in more details. But right now, I wanted to ask one question. So that might has already been mentioned. So if I understand correctly, your system tracks kind of 3 levels of aliasing levels. First is unique, and the second is path equivalence between the aliasing between 2 paths, and the third level is shared. And there is something in between here, which is like if you create a component object from 2 other objects, then that object might alias 2 other objects, which kind of is a more complex relationship than just aliasing between paths. So I wonder, I understand it's still ongoing, but I wonder, have you done some like real-world evaluation to see why this design choice would be better for the balance between usability and expressiveness?
So when you put the real-world word in there, the answer is no. That's still something that we have to do with to identify the expressive power of what we have. And yes, right now we are having the aliases with the paths in the graph. Maybe in the future, if we have some other more complex examples, yes, we will need to expand it. But also, we want to keep this approach simple and as easy to understand as possible, and again, to be conservative so that we can get precise information, also to help in the error messages that we produce afterwards. So yes, all those future paths are possible. We still don't know which way to follow, and if you have any thoughts or suggestions about other possibilities that we should include, we would love to talk to you about that. Yeah, I'm going back to the topics of discussion if anyone else has more questions.
So I'll ask a question that's too hard to answer, but I'll ask it anyway.
Okay.
You know, we have this problem where, on the one hand, if you want to optimize for usability, then you want to keep things simple and have a small number of choices, each of which is easily explained. So here you pick 3, and then you try to argue that with only these 3, you can do a lot. And then inevitably, someone comes to you and says, but if only I had a 4th, then my life would be so much easier. Can you please add support for a 4th? And you think, oh, you know, you look like a nice person. Yeah, okay. I mean, I don't want to. So, and then you end up with C++. So I wonder if there's a more rigorous way of thinking about these trade-offs, or if you've thought about like where you're gonna cut off. Like, look, I'm stopping here, no more. You want more? You know, go use Lean or Cocker or whatever. You know, some other environment. You know, is there something we can pull from, you know, I don't know, like a field of economics that thinks about like cost-benefit trade-offs in quantitative ways? How do we think about this?
Yeah, I also don't know how to think about this. The fact is that we see all this related work, and most of them you can give some even professional Java developer, and they will not be able to use them. So right now the idea is to have something that they can try to adopt. There have been some implementations of aliasing tracking in Java in the past, but the fact is that no one actually uses them. Maybe because they are still not in the point that they want to use software verification techniques or some other or to ensure some other properties. But right now, Yes, people might ask for more things in the future, but maybe that already exists in some cases, and we could maybe direct them, well, look, if you want to use more, maybe check this other work that has been done. And in this case, we want to do it as small as possible. But when you talked about that, I also was thinking that it could be interesting to allow maybe different levels of annotations, depending, for example, on the expertise of the person. So it could be also interesting to see that we could start with a small set and then maybe extend with more annotations in the future if they are not needed in the initial phase, but maybe in the later one. I don't know, but the trade-offs between the expressive power and the usability are always difficult to measure. And yeah, maybe if you find something from the field of economics, let me know.
Do we have any economists in the room?
To add to that, I mean, I should clarify, I'm Conrad. I am one of the people on this. I've been doing a little bit of thinking on this, and there's one important distinction of this work from other work, and that is that this is completely separate from like the logic layer of the verification. And we can actually use that to get to some of what you were talking about, like how do we address more complex stuff. And the idea here is that uniqueness gives you very interesting properties that make it easy to reason about both in tools and by people. And so that's really nice to have. And so that's sort of like the main trade-off of our tool is that we just care about uniqueness. But then if you combine that with the integration here, we're like, our overall goal is to incorporate this into some general purpose verification tool, like liquid types. And then the idea is that you could specify more complex aliasing relations based on some, like you have like a unique container or a unique, something that tracks your, a simple state that then you can write more complex specifications about how that relates to the structure of other state. And I realize that is like very abstract and maybe hand-wavy, but that's sort of how I think about like how are we going to push the expressive power of this is to couple it with some other reasoning techniques. And so, but I think that the core premise of this tool is that uniqueness is good and like all by itself, and it gets us a lot of what we want. So, yeah.
So I guess, you know, a gradual approach is one option. I wonder, I'm just sort of thinking out loud, right? Like, is there, so a gradual approach involves a lot of, I'll say, compatible approaches with sort of a question of when you're going to do the checking, right? But I wonder, I'm just thinking about this Hetty project, if you're familiar with Hetty, where you have actually different incompatible languages, and then you have like more stitching to do with the seams if you're going to allow them to work together. I don't know if there's something there either. Any last questions?
So I have a question for the audience. One design thing that actually Katerina didn't talk about a lot, but that we've been thinking about is what our annotation that we use as owned. So in some prior work, that's called borrowed or lent in one of my prior systems, as Katerina mentioned. We're calling it owned from the point of view that it's owned by the person who passes the reference in, and then it remains owned afterwards, as opposed to unique, which feels more like a directional annotation. So that's the motivation. But I wonder, is it confusing? I mean, given that Rust at least talks about borrowed, should we be using borrowed? Are there opinions on that?
Yeah, I found it confusing.
You think Rust is confusing?
No,
oh,
for Rust, I found it confusing.
You found this confusing, okay.
That's just because it's an inherent clash of terms, yeah.
And the language will call it not. So it's something in and something out, and the thing is unique.
So I can also ask, do you have any ideas about how we can evaluate the usability of latte?
So I'll ask a question. What hypotheses do you have? Like, are there cases that you think are going to be better in latte than in other systems, or vice versa?
Yeah, exactly. We have a lot of options. That's a little bit the problem. We could try to compare this with other techniques, for example, in terms of having people use other techniques and use latte and see if there is a correspondence and if it is easier. We could try to evaluate it by itself. The hypothesis would be that it should prevent more bugs and also be easy to understand. But we are not really sure how to do this yet.
I'll just say, I think to me, one of the most interesting questions is, people will have to contort their way of thinking about how to write Java in order to fit with the contours of your static analysis. And the same thing is true in Rust, right? It's something I think about a lot. How do people change their mental models to fit the rustic way of writing code for their specific alias analysis, which is based on lifetimes? And sort of the gap between how someone intuitively approaches a problem versus how the tool expects them to approach the problem, understanding that gap, and then understanding how hard it is for someone to cross that gap, I think are two of the most important things you can get at. So I realize I'm not proposing a specific study, but I think if you're just thinking about what kinds of questions, that to me is really the critical one, is what does it mean to change your way of writing software to work with the tool? Because you're going to have to do that. I was telling some folks just yesterday, there was a great post from Terry Tao on Mastodon about writing lean, and he was talking about like, oh yeah, this is totally not how I think about writing proofs. I had this like great intuition for the theorem I wanted to write, but now it's like, which tool in MathLib do I reach for? It's just a completely different approach to like actually writing lean proofs, which probably isn't great. But anyways, there's lots of cases where you have to shift your mindset to work with it, to fit within the bounds of the static analysis, and characterizing that I think would be very valuable.
Yeah, interesting. Thank you.
So we could continue a lot longer, but I think people might want lunch. So let's have one more round of applause. Thank you.
Quiet, Cyrus. All right, hello everybody. Welcome back to the afternoon session of Hatra. This is the interactivity and visualization for programmers session. And first up, I have a slight conflict of interest. We have debugging trait errors as logic programs presented by Gavin and co-authored by me.
Thank you for the very warm welcome, Will. Yes, so my name is Gavin Gray. I'm a master's student at ETH Zurich. Today we're going to be talking about trait errors. Of course, this is going to be a little bit related to Rust. Will is on the paper. And the reason that we're talking about them is traits are used for lots of crazy things, sometimes abused. So in the top, we have the fourth programming language. This is used in a macro, and it compiles into a series of traits, which are run at compile time. In the bottom right here, we have a maintainer of a large library, and they are in the GitHub discussions admitting that previous iterations of the library actually crashed the Rust compiler because they sort of are abusing some of the type safety that traits give them. And in the bottom left, we have a very readable and easy to look at type declaration. Everything there is a type, and for the rest of the presentation, hopefully you don't have to look at that. So we're going to try and get away from it. But the important thing here is that all of these are complex. And the compiler is trying to give, diagnostics for these things when something goes wrong. And diagnostics also don't give us the most information. And we're going to be looking at why and sort of our proposal for a solution. But first, let's do a quick run through of what traits sort of look like in Rust and why they're important in this case. So here we're defining an into string trait, and this is establishing sort of a unit of shared behavior. If you're familiar with Haskell type classes, or even interfaces in Java, this should be a familiar concept to you. Then in Rust, we can associate a type with a given trait. So here on the left, we're implementing our into string trait with the type tuple of integer. Now on the right, I have written this in sort of a pseudo-logical syntax. So this is declaring a fact that the type tuple of integer does implement into string. That's a fact that we give the compiler. And this sort of logical notation gets rid of a lot of the other cruft, for example, the method implementations for the trait. We're only caring about the types and the traits involved. The next type of definition we have is a parametric implementation. So here we're associating the type vector of t with the into string trait. But it's parameterized over type t, and we are also saying that t has to satisfy some condition. That's what this funny little t colon syntax is saying, well, the elements of t, the type of those elements, also need to implement into string. And so then vectors of those elements implement into string, but vectors of elements whose types do not implement into string don't work. And in the logical syntax, this corresponds to a rule. So, familiar, we say vector of t implements into string. That's the consequence, but the condition is that t has to implement into string. Then at the bottom, we have some client code. We're constructing a vector of tuples of integers, and we're calling toString on v. And so in order to type check this, the compiler is going to look at the type of v, and it's going to query sort of the facts and the rules that we've built up, and it's going to ask, does a vector of a tuple of integers, does that implement into string? And so we're going to go through sort of what the type checker does, and we're going to trace it in a Prolog-esque fashion. Been presenting these rules and facts in this Prolog notation, and we're going to stick to this relationship between Rust traits and Prolog. So we're asking the question, does a vector of tuple of integers implement into string? Then we come across the rule that says, well, yes, if the elements of that vector implement into string. So the type checker will sort of unify that variable t with our tuple of integers, and this condition is now pushed onto our search tree. We then later come to this fact in our database that a tuple of integers does indeed implement into string, and therefore the answer is yes, this is a well-formed and well-typed expression. We, of course, care about the cases when things go wrong. So let's modify our client a little bit. We are now constructing a vector of strings, and the query that the type checker now runs is, does a vector of string implement into string? And we can, of course, go through the same steps. So we start out with the same query at the top, vector string implementing into string. The compiler then finds that rule, tries to use it, and then it has the condition that string has to implement into string, which, funnily enough, it does not in our code. So the answer is no. And this is a type error. And how Rust presents this type error to the user is really important. And in this case, I claim that it is a good error. So at the top, it's telling us that, vector string, you can't call toString on that. That's good. That's sort of the high-level error. Down a little bit, it gives us these notes. It says, well, string doesn't implement into string, and vector string doesn't implement into string, and then ultimately, this is sort of the root cause of our problem, why the program doesn't compile, is that string doesn't implement into string. And at the bottom, it even gives us provenance. So it highlights the rule in the code, that parametric implementation. It highlights that and tells us this is where that string condition came from. That's why string has to implement into string. This is, of course, a smaller program than you would find in the wild or write yourself. And we care about, in the ecosystem, the libraries that use traits quite heavily and how this interacts with diagnostics. So, these are all examples of libraries that use traits heavily, and we're going to be focusing on one in the area of game development, just because of our familiarity with it. And it's called Bevy. And one of the funny things about Bevy is that it touts that it is a refreshingly simple data-driven game engine, but we want to inspect this simplicity. Does this claim really hold? This is a hello world example from sort of the Bevy documentation. So the model of Bevy is that there exists a world, and inside that world there are resources. We then define these functions. These are called systems. And a system takes in as a parameter a resource from the world, and then it can act on that resource. So you might have a player, you move their position. In this case, we have a timer, so we're declaring that resource here, and then we have this system run timer, which in theory could just increment the timer. And this code is good. This code runs, is perfect, not a very exciting game, but you can run it. If we modify the code to reflect a common user error, so you might not have seen it. In that middle, we're removing the little res wrapper around timer. And the problem here is that timer alone doesn't implement a trait bound called system param, but a res of timer does. So we would hope that the diagnostic would tell us, well, timer doesn't implement system param, but if you take res of timer, it might. Timer nor system param is mentioned in the about 30-line diagnostic. So that's a little disappointing. This is the diagnostic. Please don't read it. But we will look at it a little bit later. But the point is that it's long and I think a little confusing, but none of the information we really care about is in that diagnostic. And we want to know why and how we can get over this gap. The first thing is documentation, right? We provide developers documentation. They should read it to understand our libraries and how to use them. But for this specific error, the information spans across 3 pages, and there are 92 trait implementations on those pages. Trait implementations that look like this. This is 1 1/4, and there's 92 of them. But in the actual error message, there's only about in the error that we create, there's only about 6 relevant of these implementations. So the developer now needs to sift through all of this information and try and find what is really relevant to the core cause. And unfortunately, the compiler wasn't providing that information. So we're going to play the same game that we did before with our simple example, and we're going to trace the type checker and see what things it touches when trying to, see whether or not we have a well-formed system. I have translated the Bevy library into a series of logical clauses. Again, don't read them. We'll step through them one by one. But the main thing is that we have our function, which has a single parameter, timer, and we want to know if this implements into system. And so that's the top of our search tree. We then have these 2 rules. And it says, well, we can implement into system in one of 2 ways. It can be something called an exclusive system param function, or it can be a system param function. If we look at the exclusive system param function, this is only implemented for functions whose first argument is the world. Our function takes a timer, so those types aren't equivalent, and so the answer is just no. We then sort of backtrack and look at the other alternative in this tree, and we are trying to implement, system param function. And we find this rule that says it is implemented for functions of a single argument, and that argument has to implement system param. If we look at the rest of the facts in our database, we see that timer is a resource, and system param is implemented for resources that are wrapped in that res, but timer itself does not implement system param, and so the answer is no. And this is why we get the type error. Comparing these two side by side, hopefully there is sort of something obvious. In the top case, we don't really have a tree, we have a stick. And so the compiler can look down this linear set of conditions and say, okay, well, string doesn't implement into string, that's definitely the problem. So we'll talk about that in the diagnostic. In the bottom case, we have this branch. And the branching point is whether our function implements into system. And in this diagnostic, into system is the only trait that they talk about, because the compiler will not go below that branching point. It isn't going to try and infer what the developer meant. It could have meant, they could have meant an exclusive system param function or system param function. It's not going to guess for you, so it's just going to talk about into system and leave you to sort of do the guesswork yourself. And this is, fine. We have one branching point. We could, in theory, propose both of the solutions to the user, and they could then analyze each individually. But as I tried to allude to before, traits are really a Turing-complete language. And debugging a trait error is debugging an arbitrary program. And the compiler is trying to do this with heuristics. So we've been looking at this single case in isolation, but really there's a whole ocean of these cases where we have a heuristic, it fails, and so we're playing this game of heuristic whack-a-mole. One brief example is that you can get an overflow in the type checker trying to evaluate a condition. And this is essentially an infinite loop in a Prolog program. And this is just one other case where you have really arbitrary programs written into this type system. That's not great. And we view this as an interface problem. The compiler is trying to diagnose these with heuristics, thinking what is most probable, but we see this as the compiler has lots of information, and we should present this to the user in some way that they can look at it themselves and find the root cause. I think it's time for a demo. We're talking about all this visualization stuff. That is a really small text. Let's go ahead and try and bump this up a little bit. So on the left, this is the same Bevy code that we saw before in Rust. And it has the error, right, where we have a function with timer, it's not wrapped in that res. And on the right, we have traced the type checker's execution. And we see, it starts out with something called into system config, which I didn't tell you about, but it's there. And then it has a single condition that run timer has to implement into system of unit question mark. That question mark is just the type that the compiler could not infer. In sort of an ideal system, this would be source mapped back to the source code and give you that type parameter source syntax, but in this fast demo, it's not there. But we do see the same structure. So we see here that it asks whether or not run timer does implement an exclusive system param function, and then the subcondition here that it has to be a function that takes in a reference to the world. And on the other side, we see that it's trying to implement system param function. It does have, in sort of the Prolog-like fashion, this branch that unifies the first argument in our function to a type of timer, but then ultimately it comes here and asks, does timer implement system param? And the answer is no. And this tree view is fun, and it's fun to look at. I like pictures, but it's also kind of a tedious way to get your information, especially if you have trait programs that are huge with 92 implementations on things. So we have sort of these alternative views that we're trying to think about. In this case, this is sort of a directory style notation where you can step down the conditions, and if my screen were wide enough, you would get them on the same line. But you can ultimately go ahead and see, okay, that one doesn't work, and also we come down this way, and timer doesn't implement system param. An even more alternative view is we can invert the tree. So instead of going top down, we can see, okay, what are the leaves that failed? Present those first, and then users can traverse back up to the root of the tree and find sort of the sequence that got them here. And this is sort of gives you the most relevant information. It says, timer doesn't implement system param, and run timer is not of this type. And timer implementing system param is the information that we were actually looking for. Now I need to find my slides again. So that's a brief demo of sort of the pre.00001 implementation of this interface that we might give to people to diagnose these type errors. But there's also lots of other data that the compiler has. So here's a nice tweet of somebody saying, did Rust just write my type name to a file because it was too long? And the answer is yes, it does this a lot. Types get really large. I'm not even going to bother trying to tell you what this type is at the bottom because it goes on for a really long time. But we can think about presenting this information to a user in sort of an incremental fashion. So we can abstract away some of those generic parameters. In this case, we have a load query and a select statement. This is for a SQL library. And then we can give users the option to sort of look into that information as they might want to. So they can incrementally look at stuff, and maybe they see already, oh, well, this doesn't really look like the type I wanted it to, so I need to figure out why this is in this shape. So hopefully I have told you about Rust types and presented sort of their strong relationship to a logical system. We talked about a little bit the way in which we would give people an interface to search for the different constraints that are involved in their types. We also talked about sort of in this middle part how we might be able to abstract more data and give it to people in an incremental fashion. And we ask you, the Hatra community, the human aspects people, how would you design a trait debugger? Like, am I taking this from the wrong direction? Are there other related problems where this approach could be useful? I was talking to someone recently about debugging cock tactics, which shares a lot of similarity. And then also, if you were to want to use a tool like this, what sort of features would you hope that this interface has? And I hope we can open up for discussion. Thank you for listening.
All right, we have time for some questions.
Thank you for the talk.
Thanks.
So you showed this idea of debugging a program. In a program, you often have comments. So you were sort of showing the implementations and constraints that come from directly the source code without putting them into context. And so first things that I would wonder is if you would be able to add comments to these implementations to show them alongside of what is actually going on in this tree view. And more specifically, I know that in the Rust compiler, there's the system of providing more helpful error messages for certain missing trait implementations. And my question is whether you looked into that and whether you want to generalize it, and you look very happy, so I guess so.
Thank you for the question. So yes, the interface, if I understood correctly, like if it can provide comments and such relating back to the source code, it would hopefully map everything to the source code. So it would show you where the subconditions came from, which of those implementation blocks it tried to use, even linking to things like documentation and saying, here's that implementation if you want to go look at it. Yes, the Rust compiler does have some internal things, and from what we have looked at, a lot of the direction the community is going in is giving mechanisms to library designers on sort of tailoring some of the error message that they get, but we want to think of this in a domain general way. We don't really expect that every maintainer is going to provide perfect annotations or even annotations if they have a small library, so we want something that works in the arbitrary case. Other questions? Yeah.
So here you're modeling the type checker as this evaluation of a logic program, right? And I don't know if it really works that way or it's just a useful model, but in either case, it tries to do some unification at the leaves where that question got replaced with a timer, and then that affected what later branches looked like, but only in the branch where it got unified, right? So I'm wondering if you have thoughts on what's a good way to express to the user that, okay, these unifications are applicable to this branch and they don't carry across, or what order, because I think running a logic program in your head is something we're not really used to doing because we don't work with logic programs that often. And I do think it is related to debugging Coq tactics, because often the unification fails at some point deep in the tactic, and that's not the error message you see.
Exactly.
So yeah, what are your thoughts?
Yeah, so the slides that I cut out are actually the large history of debugging prologue, which focuses on sort of how can we show the control flow and the unification between values and those different variables. I got rid of those slides, but we could do something very similar with this tree here. And context is another thing which we can talk about for a long time afterwards, like come see me. And I sort of forgot the last part of your question. If you want to just repeat it, or if there was one.
Which part?
I don't remember. I don't remember, but hopefully that answers your question. Sorry.
Okay, if you think of another one, you can ask a second question.
This is neat, thanks. When I think about debugging, I think about kind of a sequence of backup plans. So like plan A is like, I really don't want to understand this. I just want to like fix it. And then when that plan doesn't work, you're like, okay, I'm going to have to like really understand what's going on. And when I say really understand what's going on, there are different sort of levels of commitment. Like the first level is like, okay, I'm going to go read the documentation and understand the model. And then there's like, oh, I'm going to go like browse the internet and understand sort of the edge cases for the model. And then eventually you get desperate and you're like, okay, I actually have to understand this thing. I'm going to read the source code, right? And so at some point, to debug your program, maybe eventually you end up reading the source code to the trait checker. And so I guess the question that I'm asking is, what abstractions do you want your users to develop regarding the trait analysis? And how will you align those abstractions with the debugger that you're providing? In other words, it doesn't really have to be a Prolog program if you can show them a Prolog program that is true to the actual analysis, and the Prolog program is easier for them to debug.
Yeah.
But maybe there are approximations that work in many of the cases, and so they don't really have to understand the entire trait inference algorithm in some cases. But then in other cases, maybe they actually do. So I don't know how you think about that range of options.
Yeah, so I guess like the first thing I would have to say is this is how the compiler works. So we are just tracing the compiler here. We aren't doing our own trait inference algorithm or anything else. One of the things that we had hoped with sort of that bottom-up view was presenting those leaves, which in my mind would be the most low-cost way of trying to find out what actually went wrong. So in that case, we get the information that a timer doesn't implement its trait bound, but there's also some other things that were there, but they're a little more bogus, or they would take more work to sort of get it to work, right? You'd have to change the entire type signature of the function, and so I would imagine that is, some measure of how much cost it would take. We can also, sort those things by some heuristic. I was talking about heuristics are bad, but we could use them to sort them in terms of like the most probable and give users a sense of where to start. Does that answer your question? Yes.
Hi, I was just nice talk, and I really do like your visualizations, and I'm sure they could work for more than Rust. But I kind of have to say, do we really want a Turing complete trait system in our language? I mean, we're not at Popple, so I do think that is something we can discuss here.
It's a good comment. Unfortunately, I'm not the developer of Rust, and so I can't, get rid of the trait system, but it is something that we work with in a lot of languages, Haskell, Scala, OCaml, etc. So.
Yeah, I just wear the t-shirt.
Perfect.
So I really like this, taking the idea that these are logic programs literally instead of just that happening to be how we tend to abuse these systems. Have you thought about there are other executions for logic programs like Datalog that's a little more forward-facing, so you could pose, questions of, here are the things we can conclude about this type, and then you can, maybe mix forwards and backwards kinds of reasoning there?
I have not personally thought about that in a sense, no. My mental model has sort of been shaped by how the actual implementation of the trait system is, because we are trying to handle the entire domain of problems that people can write. But it would be an interesting thing to sort of think about. Thank you.
You can also not take it too literally, right? These are not logic programs. They are traits in Rust. And there's one specific limitations here, which is the orphan rule and this trait coherence system in Rust. So in particular, asking about features you might want in the system is when the search for some implementation is happening, you can restrict this based on which types exist in a module that cannot be implemented by the user, for example. Any thoughts on that?
Yeah, so thank you for mentioning coherence, because the implementation of this game library has to sort of get around coherence in some way, because orphan instances are disallowed in Rust. And so some of these peculiarities are sort of Rust specific in how the different constraints the language puts on it, but we go off of what the type checker does.
Yeah, I want to emphasize one thing for clarity is, I think there's a bit of confusion about is Prolog really in the Rust compiler? And I think it is useful to think about as yes. There is literally a Prolog interpreter that is in the Rust compiler, and that these trait queries do literally become not strings, but basically Prolog programs. And because coherence, I'm pretty sure, gets enforced above that layer. So the trait solver is not aware of coherence. By the time it reaches that, it's just doing basically Prolog interpretation. And so we are presenting it that way, but that's, I just want to emphasize that we're not doing any interpretive work. We're not building a model and saying you could think about it like this. This is actually how it is. It's just not how the information is usually presented to Rust users.
Going back to the earlier comment about alternate ways that you could approach this problem of, you said that there's a way they're building a way to let library authors make annotations, which that was what I was originally going to ask about. I was like, oh, that sounds super cool. And the reason that I asked about this is because in my experience with Rust and with TypeScript, having recently written a really gross type hackery library in TypeScript, is that there's kind of cute libraries that use the language the way that it was maybe meant to be used, and then there's eldritch horrors, like the crates that you listed on your earlier slide. And I guess in my mind, my intuition is that you could just use Rust as it is for most of the crates, which are probably mostly going to be cute, and then put a little bit more library author effort into the eldritch horror ones like this, and then you should be mostly done. So I'd be curious if is there any related work on what percentage of libraries do stuff like this that needs this Esther work on top of it, or not?
So I don't know of any work that classifies or categorizes what percentage of the libraries use traits in this way. It is, there's enough of them that it comes up quite frequently on discussion boards, Reddit, Stack Overflow, things like that. And when people are trying to develop these, general libraries for game development or for web development or, SQL, object relational mapping, they rely on these things in order to be sort of simple and flexible while still getting that heavy static, type safety. So I guess the short answer is I don't know.
So we should probably move on, but maybe as we're transitioning, I wanted to ask one question myself. This reminds me of Amy Coe's dissertation work, in which she looked at the problem of not only why did something not happen that you wanted to happen, and it seems like this is an instance of that. And I wonder, have you thought about proposing fixes or searching for fixes that would bridge that gap? Not just showing you the leaves of the tree, but how could we extend the tree maybe to make this happen? Because that's what the user actually needs to do.
Yeah, that is a really great. That's kind of makes me think of proof repair in a way of we have some proof tree and we need to repair it. I'm not a program synthesis expert. Maybe we'll tack that on to sort of the end of the project, but for now we're trying to focus on maybe the basics. But it's a good direction to extend to.
Yeah.
Thanks.
Cool. Well, let's thank our speaker again. Right. The next speaker is Cyrus Omar, who will be talking about totally live programming with Hazel, progress report on the overall project. And this is joint work with Andrew Blinn and David Moon, all at the University of Michigan.
That's where I was hanging out this past weekend, down in the south of Portugal. Hold on, I need to.
I feel like many of us have opened that map with Humberto Delgado Airport on it.
Okay, there we go. Oh, no, still not quite. I need to have this be mirror. I am doing a live demo, so I need to see what's going on here. Okay, I think that's it. Cool. Okay, all right, so let me start by saying that the Hazel project, I have my PhD students Andrew and David listed here, but it is a big collaborative project. There are, at this point, I think maybe 60 contributors to the Hazel project. I couldn't list all their names here, but the demo that you're going to see is a big collaborative effort. Many of them are undergraduates at the University of Michigan in my lab, the Future of Programming Lab. So this is really a summary of a lot of the work that we've been doing over the past several years. There isn't really new results here. If you've been to like all of the Hazel talks at all the conferences, you might have seen everything in this talk. I just wanted to kind of bring it together. So the motivation for Hazel is really that programming today is not just opening up Notepad and writing code, right? Programming is really assisted. It's kind of a collaboration between us, human programmers, and programming environments that offer a number of language services, okay? So everything from syntax highlighting to code completion to go-to definition, all of those things are language services. They rely on the semantics of the language to provide you services. You can see that there's all these extensions that are specific to different programming languages and VS Code here. And we want these things to be available at all times as we code. In fact, we want them to be available in particular in these situations where the code isn't complete, right? That we're still working on the code. And there's a problem here, right? So when we are designing a programming language or defining a programming language, if you're defining standard ML, you write a book and you give all the rules for the grammar and the type system and the operational semantics, and all those rules are sort of positive rules. They tell you when a program is well-formed, is well-typed, has a result. Right? But when we're actually writing code, that's not always the case. In fact, there's data to suggest that that's not even commonly the case when we're writing code. So you'll have transiently, or even sometimes for a long time, especially if you're a student, you might have a syntax error, okay? And that means that everything else is meaningless, right? You have to fix that error before anything else can happen. Any of these tools, these services that we rely on, require that not to be the case. And then even if you don't have a syntax error, if you have a type error, that means that you can't run the program, and so you won't be able to get any feedback even about the parts of the program that maybe are working correctly. This is particularly relevant. I'm sure we've all encountered situations in our coding lives where we make a change to a type definition, and that change is going to require a number of downstream changes to a number of different functions, and those changes are going to take maybe days to resolve, right? That whole time we can't run any of our unit tests. We can't actually demo the code. We have to pull up a different branch to show it to our friends. Right? And so this is a problem that isn't just transient, it's a problem that can persist for a long period of time. And then there might be runtime errors, sort of things that we didn't expect to happen at runtime that cause the program to, again, crash, right? We don't recover gracefully from these things. They typically just cause something catastrophic to happen. And I also want to point out, I won't talk too much about it in this talk, this is kind of ongoing work, but another way a program can be incomplete is when there are merge conflicts, when we're collaborating with other humans, or maybe AIs or something like that, right? Maybe we have some disagreement about what should be at a particular location in the code, and if we get merge conflict, it looks like this. This is going to totally flummox our parser or our type checker. This is not going to make sense to any tooling downstream of that, and we have to resolve these things before we can move on. So this gap, we call this the gap problem, that there's these gaps in these services that we rely on to code, as we do normal things when we're writing code. And so a lot of the work that we've been doing in the Hazel project over the last several years is rooted in solving the gap problem. And one way to do that is by starting with the syntax bit by using a structure editor. Okay? And so this idea of a structure editor has been around for a long time. I'll show you some examples in a bit. But the idea is, instead of leaving the program in an unparsable state, you insert holes in the right places, and then you allow that hole to be a part of your syntax, and then you have to just reason about programs with holes in them. Okay, so you can handle missing parts of your code with a hole. You can also handle erroneous parts of your code by sort of thinking of the hole as a membrane around the error, and I'll show you examples of that. And then once you have this sort of, once you've sort of eliminated this kind of parse error, then you have to think about the semantics. And so you have to develop semantics that understands holes. And a lot of the papers that we've been writing over the past several years have focused on this problem of semantics for holes, with the goal of this sort of totally live programming experience, where there are really no editor states left that are syntactically, statically, or dynamically undefined. There's no undefined behavior. It's defined in some way. It handles it, and ideally handles it gracefully. This Friday at UPSLA, we'll have a paper on pattern matching with holes. How do you reason about exhaustiveness and redundancy checking when you have holes and patterns, and how do you run a program that has holes and patterns? So that's this Friday. We have a couple of other papers that I'll talk about here. And so a lot of the effort in the Hazel project has been taking this idea of total liveness, turning it into meta theory, and then proving theorems about it. So this is a key theorem from our POPL 2017 paper. You don't need to understand all the notation here, but the idea here is you can define a semantics not just for your operational semantics, but for your editor semantics. And so that's what this, let me see if I can, am I loud enough here? Is there a mic? Okay, so I just want to point at some things here. So this judgment here is a transition system for edit actions. Okay, so you're taking an editor state and transitioning it to another editor state, and typing is preserved by that transition system. And so that means that you never have statically undefined editor states. And this is a theorem that we've proven in AGDA, right? So we have a lot of good theory for that. That doesn't mean that every editor action that you want to perform is well defined. So at a paper that's coming up at POPL in January, we have another theorem that says, in fact, you can take any editor state and mark it with errors, with holes in the right places, so that every action that you want to take can be performed. So we have a number of things like this related to operational semantics. So all of these papers here are available to check that out. And so, you know, problem solved, right? Someone commented about this is UPSLA, so it's not POPL. Well, we got one UPSLA paper now, so problem solved. Well, the problem's not solved, okay? So you know, if you just use all of this theory, you end up with action semantics for which the usability questions are really kind of unclear. In fact, if you use the system in POPL 2017 and try to code, you're going to have a bad time. It's going to be really much less productive, despite this total liveness, than it would be to just use something like VS Code. So it's not just about solving it's necessary to solve the gap problem, but there's another problem that comes up whenever you start involving structure editing, whenever you start needing to insert holes. And we call that the viscosity problem. Oh, sorry, this was a joke that I forgot to do. It's a cat joke, so I'll do it. If you don't want to think about the theorems, the way to think about this part of the problem space is if your cat runs across your keyboard, most programming languages won't understand. You know, APL excluded maybe. And with Hazel, when you solve the gap problem, it will understand what your cat says. Okay? Okay, maybe that's a strong claim. I'm not sure. Okay, so structure editors. Maybe many of you have people in your lives that have used a structure editor. How many of you have used Scratch? Okay. Yeah, when I do this in my undergraduate class, almost everybody learned programming using Scratch at this point, if they're undergraduate CS majors. Like it. Yes. I didn't hear that, but yes. So how many of you would like to use Scratch for your day-to-day programming in your research careers? Okay, so there's some problem here, right? Scratch doesn't have the gap problem, but it has some other usability problem, right? It has this viscosity problem, we call it. And the problem here is, you know, it might be relatively straightforward to construct a program if you already have it in your head by dragging the blocks in and out. That's a little bit inefficient without a keyboard-driven interface. But once you have a big enough program like this, right, it becomes really hard to imagine restructuring this thing in an efficient way because you have to kind of like do tree rotations and transformations and pull things out into Scratch space and rotate around the blocks, right? And so a text editor is just a much more usable interface for writing large-scale programs. Okay, well, there are other structure editors. For example, JetBrains MPS is a really great example. This is a structure editor generator, so here's just an example of a editor written in MPS. So you can see down here what's happening is as you kind of insert code, you type the dot and there's a hole, and then you fill the hole and you keep going. And so this is much more productive. You can drive this with your keyboard. And this could also solve the gap problem, right? It has these holes, and so you give semantics using the work that we've talked about before, and then you're happy. Well, this actually works really great because of a number of heuristics that MPS has about code insertion into empty holes. But this problem of modifying or restructuring existing code still throws people for a loop. So there's some data from a study by Berger et al. In 2016. This is a little hard to read, but the idea here is if you talk about insertion, people really like, both experts and novices to MPS are sort of happy with the insertion interface. But with deletion and selection, and let me just talk about those. With those two operations, actually, there's a lot of unhappiness. And the reason for that is it's still, although it looks like a text editor, everything is projected into a textual view, it is still a tree editor at heart. So when you delete, for example, the plus between 2 and 2, you're deleting the entire plus node, or one of the plus node plus one of its children, and you're just leaving one side or the other. And so people perceive this as an inaccuracy in how deletion works. Even experts perceive this as an inaccuracy relative to text editing. So these two dots are not here, that's text editing, and that's novices and experts. Okay? Selection also is tree-oriented. And so when you select something, it selects more than, you have this kind of spooky action at a distance where you mean to select something right next to your cursor and it selects this whole big thing. And sometimes that can actually be helpful because you're often operating at the level of the big thing. But other times for certain kinds of restructurings that I'll show you, that's really not what you want. Okay? So the fundamental issue, another way to think about this fundamental issue is the affordances that you get as a user suggest that it's a text editor. The way it looks, the way the keyboard handles, suggests that it's a text editor, but it's really still a tree editor, and nearby things in the projection, in the textual projection, are not nearby to each other in the tree in all cases. Right? So if you think about like 2 times 3 plus 4, the 3 and the plus are adjacent to one another in the textual projection, but there's like a parenting relationship that goes up a couple of levels to actually get from the 3 to the plus. And that can be arbitrarily deep. So you get what I like to call spooky action at a distance here. Okay? So we did a study I'll talk about in a bit, but here's some quotes from, we compared some of what we're going to show you with MPS, and one student said, MPS was extremely cognitively demanding me. It felt like I was solving tree manipulating puzzles the entire time I used it. The worst part by far is the lack of Scratch workspace. I think that comes from using Scratch where you can drag things into the margins. And several people, I think unprompted, mentioned Towers of Hanoi as what it felt like to work with MPS. Okay. If you're not familiar with Towers of Hanoi, it's like a little puzzle game where you have to like move things around by like putting things into temporary Scratch space, and it's like a lot of tree rotation stuff. Okay, and maybe you could get used to that, right? And there's some data to suggest that if you like get used to this, if you spend enough time learning this, maybe you can get productive with it. There are industry users of MPS. Okay, so this is a very cool project, very ambitious project, but I think there are still some problems there. And so to get back to the problem, so solving the gap problem is critical, but so is solving the viscosity problem, the human aspects of this. And so what I want to show you in our demo is some of the work we've been doing specifically on that in the new version of Hazel. And the sort of terminology that we're using here is this idea of gradual structure editing. So where the structure is sort of, you can gradually destructure the structure and really get a much more textual manipulation of the program, rather than having to think with tree transformations. But there is always still a tree. And you can, in fact, use the tree transformations if that's the most natural thing for you to do. But you can destructure things gradually as needed. So it's kind of similar in spirit to maybe gradual typing, if you're familiar with that idea, where you can like choose whether to put type annotations. You can choose whether to work in a structural or destructured way. So let me pull up the demo. Put this down somewhere. Okay. Okay, so Hazel is a web-based editor. So you can go to hazel.org and play with it if you want. When you open up Hazel, there's a few different modes. I'm going to just show you Scratch mode for a minute, but there's an exercises mode that students use that I'll show you in a moment as well. So Hazel is a live functional programming environment. So when you start in this mode, you get a cell that contains a single expression, and it's an empty cell. But in fact, it's not empty. In fact, it sort of has something in it that it represents emptiness. It's a hole. Okay, and if you look closely at this hole, it's a little hexagon, and even the cursor next to the hexagon is pointed to indicate this is like a convex hexagon. The left and right tips are convex. Okay, and that'll become important in terms of developing intuition here. So anyway, I can fill the hole. If I fill it with a number like this, you can see what's happening is it's operating like a little calculator. So if I type in a number, it's evaluating it as I type. Okay, I'm not hitting enter, I'm not hitting run. It's a live environment. It's running code as I edit. Now, so what happens if I type times here? So you can see, although it was, I pressed space and then times, so it feels like a text editor, but what happened was, after the times, it didn't just leave it in a parse error sort of state. It inserted another hole, a hexagon there, and so that means there's not a parse error, right, because that hole is part of the syntax. And so now I just have to fill that hole, and if I fill it with 2, I get the result 6, as one would expect. If I delete it, I get the hole back again. Okay, so all hole management is automatic in Hazel. You don't have to ever manually insert a hole. Okay, cool. If I go over here and I delete the times, what would happen in other structure editors would be you would delete the entire times node, right? Or maybe you would delete all but one child. Which one do you leave behind? I don't know. It's like asking what who your favorite child is. That's an arbitrary question, right? There's no good answer to that. So here, you're not left with one child or the other. You're left with a different kind of hole. This is an operator hole, and you can see it's also a hexagon, but it's a concave hexagon to indicate that it's an operator. And so there's this hexagonalization metaphor that's really critical to understanding this, where like an expression is a convex hexagon, and to insert holes, what you have to do is make it a hexagon again. So if I just left 2 and then plus here, without that hole there, it would be not a convex hexagon because the right side of the plus is concave, and so you insert this hole to make the pieces fit together, just like kind of a block editor, but you end up with the overall shape being a hexagon, convex hexagon. Okay, so that's what's happening here, and the same idea here. If you put 2 convex things together, you have to put something concave to glue them together, and that's the hexagonalization kind of Lego metaphor here. All right. Now, if I press plus, again, you get a hole on the other side, but now you observe something maybe slightly interesting is, although there's a hole here, the runtime system does not sort of crash when it sees the hole. It's not like arrays unimplemented or something like that. It's running the code as far as it can. It's doing the 2 times 3, and then it's saying, well, I don't know what to add to the 6, so I'm going to kind of leave it at that. And it's also it's a pure language, so you can kind of reorder things or skip over things as you wish. So you can go over here. You can set white space up as you want, by the way. It skips over the hole. It does the 3 times 4. It tells you you're adding 6 and 12, and then leaves the hole in the middle. We don't get so aggressive as to apply algebraic rewritings or anything here. I mean, that would be non-deterministic, right? Is it 18 plus hole or hole plus 18? Okay, so you get this you get this automatic management and also this sort of like live evaluation even in the presence of holes. So I've shown you empty holes. These are empty holes. You can also have non-empty holes. So if I put X here, excuse the multiple rendering of the error box here, but so that's the standard sort of error that a compiler would give you. You can even see it down here at the bottom. Oops. X not found, right? So that variable reference was not found. Normally, that would have the gap problem. So you try to put this through a compiler, it tells you that error, and then it waits for you to fix it before it can execute this code. Here, although it is a static type error, all the complaints about static typing preventing kind of like exploratory programming are alleviated here. Well, maybe not all of them, but many of them, because you're still running the program. It's just like propagating the static error to runtime and treating it like a whole. So it prevents the addition operations here from proceeding because there's no number to add, but it shows you that what you're trying to do is add something to 6, not just to 2 times 3. Okay, so hopefully you're getting the idea there. If I put true here, you'd get the type error, bool inconsistent with expected type int, but you would still get an execution with an error in the result. Okay, so that's one aspect of it. I've only shown you kind of simple arithmetic so far, so what about more complicated syntactic features? So the Hazel language is a typed functional language. It has algebraic data types, pattern matching, a module system, so it has all this fun stuff, but that requires fun syntax. And so what happens if I want to, for example, bind this expression that I'm still working on to a variable? So I'm gonna write a let expression. I can just start typing let. When I press space, what it does is it doesn't actually try to fully structure the code. So this is the gradual destructuring I'm talking about. Okay, so it says, okay, you're trying to insert a let, but I don't actually know if you want this existing expression to be the bound expression or the body of this let. Do you want this to be bound to X or to be the place you use X? And so what it says is, well, I'm waiting for you to first name a variable like X, and then to type equals, okay? And that equals could go here, in which case I've bound X to this variable, and then it says I'm waiting for you to type in to tell me where you want the in to go. And the in could really go anywhere here, right? But probably we want it over here. So I can go over here and either type in or press tab to autocomplete. And now I've returned structure to this program. But I could have gone the other way. So instead of putting the equals in the in here, or sorry, the in here, I could just put the in down here. And then what have I done? I've said I'm going to bind a variable X. I haven't told you what it is yet, but I'm going to be able to use it in this expression. So that was a choice that we had to make when we sort of wrapped the existing code in a let expression. And that could have been like 2 different tree actions determine, you know, that which action you invoke determines where the existing code ends up in the subtrees of the new form. But here, it feels much more like text editing. In fact, it feels almost like assisted text editing, where it reminds you of your syntactic obligations as you're typing. And this is actually really great, and I'll talk about our experience in the classroom in a moment. It's really great for students that are not familiar with functional programming and have never seen the let in construct, right? Maybe they're familiar with semicolons ending the let, and semicolon has a different meaning in this language. But you know, those kinds of errors we believe, and we're still doing all the data analysis, we believe that those kinds of errors are reduced by this syntactic assistance that's provided here. Now what we don't do, you might notice in this state, is I made this bold claim that every editor state in Hazel is meaningful, but you see this question mark at the bottom for the evaluation result. So this is ongoing work. Basically, when something's in the backpack, it's like there's something destructured about the state, and so it's hard to evaluate in this destructured state. But what you can do is sort of heuristically place the in a place following the same kind of logic that a error-correcting parser might use. But where an error-correcting parser only has the ability to sort of delete lines and insert tokens, we have the ability to also use holes to figure out where these things should go. And because the previous state was well-typed and well-formed and runnable, we could even use other heuristics, right? We could determine sort of like what do we think the user's doing, and that might allow us to play, or where do you think the user's going? Well, we know they're probably not trying to insert a type error, so maybe insert it in a place that minimizes type errors. So we're working on all that. I don't have a demo to show you of that right now, but maybe in a week or 2 I will. So anyway, so that's the basic idea. So now let me show you a demo of what it looks like from the perspective of a student doing an assignment. Okay, so we have this exercises mode. I'm just going to show you a really simple exercise where we're supposed to write the odd function as a recursive function. And so we have this kind of notebook-like interface for students to work through, and we use this very test-driven methodology. So what you get is a problem specification, with some equational stuff. You get a prelude, and this is just a read-only buffer, but it's still structured, okay? So you can go, you might have noticed that there are these syntactic hints that tell you about how the system is parsing this code, okay? So that colon is connecting the not variable. You can even see down here a description of what the variable, it says variable binding, it tells you its type. This thing is an arrow type, the equals is connected to the let and the in, okay, and then the fun down here is connected to the next line, but stops before the in. Right, so if you're new to functional programming, if you haven't seen this kind of syntax, it's going to be unfamiliar. You're not going to know how to kind of parenthesize things in the right way in your head, and so this kind of takes that operation you have to learn how to do in your mind, puts it up on the screen for you. So you can explore this, you get type feedback, right? You can say that this thing's expected type is bool, etc. All right, cool. Let me show you the student-facing view. So we have an instructor view as well for creating these exercises. But the student sees the type signature of the correct implementation of odd, and then what they're asked to do is write some tests against the correct implementation to make sure they understand the problem specification before they actually go in and solve the problem, okay? And so what I can do is do some live testing as well. So if I type the test keyword, what it's asking for is a test here. So for example, odd of 0. Notice when I press open parentheses to do a function application, it doesn't close the function application. It just gives me this syntactic obligation that I need to close the parens. And then there's also an end keyword at the end of our test syntax. And then as soon as I finish that, before hitting run, before starting the test runner and switching to another window and seeing the result, you just get this little red X. And so maybe you caught the problem, maybe you didn't. 0 is not odd, 0 is even, right? Yep. So I can say not odd here, immediately get that feedback that that's a valid test, and I start getting points as well. So you get that instant gratification of now I'm not like at 0 points out of the problem, I have some points. We also do some mutation testing, so we have some hidden buggy implementations, so you can't just write a bunch of tests that test the same thing, you have to find the bugs. Then you write your implementation, so let me just do this really fast. If n equals 0, then true, else whole. So I'll leave the else branch, the recursive case, unspecified, but then I'll just go down here. There's some syntactic requirements that we test for as well. And it runs the same test that you wrote above. You can edit them either here or there. And you get feedback about, did your function pass this test? And nope, you wrote the base case wrong. So you can go back up here, change this to false. And then you can see that your test now passed. Okay, so students are quite happy with this. So let me just wrap up here with some summary data for you. Okay, so I won't go into what this shows, but it shows you basically that this is as productive as text editing for people in a lab study, and more productive than MPS. Okay, there's a paper at VLACC that was presented a couple weeks ago that has this data in it. We also did this fun heat map of sort of like if you give people code modification tasks, in a text editor, they reuse a lot of what's already been written and just kind of move things around. The heat map looks very similar for our editor, which we call the Tyler editor compared to VS Code. It looks very different from MPS, where people end up kind of deleting more than they wanted to and then rewriting it. Okay, so teaching with Hazel, we use it in an undergraduate PL class, which introduces FP for the first time to most students. 200 plus students have used Hazel at this point to complete multi-hour coding tasks. And notably, the tutorial that we give them is about what I just told you, even a kind of more condensed version of what I just told you. A 5-minute tutorial on how to edit in Hazel, then we say use your text editing intuitions. And students feel that this is a very easy to learn editor, by far the most user-friendly IDE editor I've ever used. The color designs are off, et cetera. Okay, so very, very nice comment. I'm cherry picking, obviously, but generally people like this. Okay, so big picture. The Hazel project is really about solving both the foundational PL problems, the semantics of holes, as well as the HCI problems, taking that really seriously. We're increasingly doing some AI stuff I didn't have a chance to talk about. And we want to use this to enable ambitious applications. So I talked about EdTech, but we are also interested in formal reasoning assistance for proof assistance, computational science applications, really taking collaboration seriously, and ultimately building a live collaborative commons. So think of a computational Wikipedia, where every page is a module and every element on the page is a programming construct. We really need that to be live. We don't want some editor somewhere in another time zone to go to sleep or have some coffee, and that breaks the whole system, right? So liveness is really important there, and we're building the foundations for that. So I'd be happy to talk about any of this stuff all week, and I'll take questions if we have time.
Super. Yes, we are definitely short on time, but we can take a question and then maybe another one or two as we switch over to the next presentation.
Thanks for the talk, Cyrus. I had a question about how this interacts with sort of other programming language features. So I was thinking, you know, how your live editing. So a lot of programming. You mentioned that it was pure. So what about sort of would these same techniques work for something that's mutable? With kind of imperative features, and also things like language features such as macros and such. Have you considered how that kind of might interact with your system? Thank you.
Yeah, so the editor itself, the whole driven editor, you can definitely have that editor for an imperative language or for Prolog or whatever, right? The live evaluation features are much trickier to do in a setting with side effects just because you are running the program on every edit, so you don't necessarily want to spin off a network request or tell the robot to move on every key press, right? And so you have to have managed side effects, so I think something monadic might help there. And then just briefly on the macro system front, I didn't get a chance to show it, but we have this system of what are called live literals. There's a paper, PLDI 21. It's a graphical macro system, so because it's a structure editor, it doesn't have to be text. I just focused on text here, but it can be basically a graphical macro that uses the live data to show you kind of previews of things, but then generates code underneath. And so you can integrate GUIs and code, and it's compositional sub-expressions inside the GUIs. So happy to give a demo to anyone that's interested in that after the talk.
Okay, I think we're out of time, so let's save the questions for the break, the remaining questions for the break, but thank you, Cyrus, again. All right, our next talk is Revis, an error visualization tool for Rust. And this is by Rochen Wang, Molly McLaren, and Michael Koblenz, and Rochen will be giving the talk. This is a remote talk, I believe, right? So, can you hear us? Can you say something?
Hello.
Hello, yes, we hear you. Excellent. Please go ahead.
So, hello everyone. I'm Rochen. I'm currently a PhD student at George Mason University, and today I'm presenting my work when I was a master's student at UC San Diego with Molly McLaren and Michael Koblenz. So Rust, it came about because some traditional languages are not memory safe. For example, C and C++, they allow you to dereference pointers arbitrarily. And Microsoft found that 70% of their vulnerabilities are related to memory safety problems. So, so Rust tries to solve this problem by using an ownership and lifetime mechanism to ensure memory safety without the need of garbage collection. So you have both the safety and you do not have any performance issues. And the tricky part is that lifetime related compiler error messages are hard to understand. So here is an example of lifetime error in Rust. We have a function example here that takes x, which is an array with 4 strings. We match on x, if x matches this pattern, then we assign x to a. Then we can do something, and otherwise we can do some other thing. After the match block, we pass an immutable reference of x into the function useX. But this is not valid in Rust. And this is the compiler command line error message that the compiler gives. We can see that the error exists because x is got moved to the variable a here, and you can only have one owner per value. So after the move, you cannot use x anymore in this position. In the compiler command line error message here, there are some good things that it shows the complete error information, and it also includes a help message that suggests you how to fix the error message. And but there are also some cons. First, often the command line error message is located in a separate window, so the user needs to context switch between their IDE and their terminal. And also the error message does not point out the lifetime ranges, which the learner needs to know when they are comprehending this error. And although this help message successfully suggests a fix to the error, it does not explain the error. So when the user came across a similar error next time, they may employ the similar fix, but if the fix does not work, they don't know what to do. Another popular tool that people use is Rust Analyzer. Rust Analyzer is an official extension, and this is a pop-up box when you hover on the error here. And the pro is that it is shown inside the IDE, so people can see the error with their code. But in this case, the hoverbox overlaps with the code, so in fact, you cannot see the code and the hoverbox together. And we can see how it is explaining the error. It has some location information here with some error message, which is the same as the command line error message, but they're not intuitive because we cannot see intuitively where 99 is and where 712 is. Also, the pop-up box may contain some irrelevant information, such as this unit parenthesis here, which is the return type of the usex function. And this kind of irrelevant information may interfere with the comprehending of the error. So we want to help learners understand lifetime errors with visualization. One of the existing visualization tool is RustViz, developed by Cyrus. And it is a tool used by instructors to create interactive diagrams that visualize lifetime. So it has the code on the left and the visualization on the right. It shows the lifetime of X and A. We ended up not using RustViz as our visualization scheme because we first want to automatically generate the visualization and also customize it for each error message. So I will present our tool, RustViz, an error visualization, Rust error visualizer. So our tool is a VS Code plugin that displays visualization for errors next to the user's code. We currently support 8 types of lifetime related errors. And this is a screenshot of the tool. And next, I will play a demo. So we are in VS Code right now. there is a red triangle in the gutter that shows that there is an available visualization on line 6. To display the error, we first put a caret on the line and press the keyboard shortcuts. Then the visualization will be shown. This is the example code shown in the previous slides. There is a blue region here shows the lifetime of X. And there is the purple arrow that shows where X is moved to another variable. This is where the X's lifetime ends. And the red arrow shows where X is used. And there's also a tip explaining the error. And when the user tries to rename the variable, they can save the file again to update the visualization. And if the user edits the code that is overlapping with the image, they can also save the file to update the image. And if the window is not wide enough, they can scroll horizontally to see the whole visualization. To hide the visualization, they can just hit the same keyboard shortcut. And next, I'll talk about the components of the visualization. The first is regions. Regions denote lifetime of variables. It starts when the variable is defined and ends when it is moved or goes out of scope. And it is shown here as a vertical line with endpoints. And regions can be open or closed. In this case, we are displaying the lifetime of this closure. And the closure starts on line 15 and extends after the function is returned. Because the endpoint is not specified, we have an open region here. So the next types of component is arrows. Arrows denote single events like borrow or move. And we show on line 9 that X is moved to another variable here. And on line 12, the use of X after being moved. We also include a tip for every error. The tips are descriptive text explaining the error so the user knows why the error is not allowed in the Rust language. So next I'll talk about the implementation of Revit. It is implemented as a VS Code extension, and the visualizations are SVG images. We generate the visualization from a structured Rust compiler output. So, so we depend on the Rust Analyzer extension, and Rust Analyzer will run the Rust compiler every time the file is saved, and we parse the generated Rust compiler output. So when we get the output, we first look at the error code shown here. And if this is a supported error code, we will use the location and message information to locate the lifetime start and end points and the move and borrow actions. Once we compute the SVG image, we attach it to the proper line as a line decoration. So next I'll talk about the user study. We performed a user study in a compiler constructions course, where students are most students are introduced to Rust for the first time, and they constructed a compiler gradually with several programming assignments. The study lasted from week 6 to 10 of the quarter, and during the time, students completed 3 programming assignments, which including heap allocation, garbage collection, and optimization. So for the participants, we asked them to install a build.rs script that automatically saves the whole project every time the compiler is run. And we gather all the build versions to our machine, and we build each version to obtain the errors. After that, we calculate the resolution time of each error. And that is from when the error first appears until the error disappears. And we randomly assign our participants to use or not use Redis. After the study, we gave them an exit survey on programming experience and the experience using the tool. So we gathered over 6,000 commits from 6 students, and over 15,000 instances of error messages. But only 51 of them are supported by Redis. That is 0.3%. But we find that they take 3.4%, so 10 times the program repair time. So so we can see that there is some uniqueness in Rust that causes more repair time than regular error messages. And in the survey, 2 out of 3 students which were assigned to use Redis said it was useful. And the other student reported having written 10,000 lines of Rust before the study. So the tool may only be useful for new Rust users. And on future work, because we only had 6 students in the study, we did not perform evaluation of the usefulness of the tool. We're hoping to perform a larger scale evaluation that is conducted in a general programming scenario to evaluate the tool. So one reason why there are so few lifetime related errors in our results may be that in the programming scenario, it is a Rust they are building a compiler, and the compiler is built in a rather functional way. So there are so most of the references are immutable references. So there may be fewer lifetime related errors in that case. And we are also hoping to support more error codes and improve the descriptions. So apart from lifetime related errors, there are also some other kinds of errors that are unique to Rust, such as trait related errors. And also we are hoping to add an opt-in data collection component, which can help the user to understand how they are coding, and also help us to collect data more conveniently. And that's all. Thank you.
Thank you. We have time for a few questions.
Thank you for the talk. So in the 99.7% of other errors that you saw from your study, I'm curious what were the most common errors encountered by your 6 participants in the study?
The most common, I think, is the syntax error. And it is the syntax error, and I think that is consistent with other studies that people performed. Like they also found that syntax error are the most prevalent kinds of errors.
Got it. Thanks.
All right, maybe people can introduce themselves since the speaker is remote.
Gavin Gray. So in the visualizations that you propose, there's a very strong reliance on like the linearity of a lifetime, but lifetimes in Rust can be nonlinear, right? It'd be sets of program points. And so how might you extend this visualization to encapsulate those types of errors?
So yeah, currently we only support this kind of lifetime. Yeah, and for example, if the lifetime is related to another function or another like type definition, so first we need to figure out a way to display the visualization across different places of the code, so the user can scroll between different positions of the code. So we'll probably first display all the related code together, and related to visualization, we may draw like boxes or draw boxes around the variable to show if it is owned or borrowed, and with that to help the users.
Okay, thanks.
Other questions? I have a question. This is Jonathan Aldrich from Carnegie Mellon. I was wondering if there was a design process that went into the development of the visualizations. Did you try different alternatives? Did you get any feedback on that?
And the design process, I think we just like design the visualization as we are talking, and we did not iterate many like versions of the visualization.
Okay, thanks. Well, it definitely looks very, I mean, it looks very clear intuitively, so it's a nice design.
Yeah, about the visualization, I did not know you could embed an SVG in VS Code. That's crazy. Can you basically, okay, because I've been harping on the inability to like do arbitrary decorations in VS Code for a long time. But can you basically, does the SVG mechanism let you draw arbitrary images over the entirety of your VS Code region?
So the SVG is attached to one line of the code, and so you first, I think you can also attach like PNG images and other types of images. And I think there is a API in VS Code extension. I think it's text decoration, and you can specify that the decoration is attached to the whole line, and it is displayed after the line ends. So, so the visualization also moves with the code if you scroll and zoom in or zoom out.
So you generate an SVG like per line of VS Code that you're inserting into. There's not like one SVG that you like draw over the whole region.
No, that is one single SVG attached to one line, and it is displayed.
Oh, but that
because
SVG
the height
can
is
span
higher.
multiple
Yeah.
lines. Wow.
Yeah.
Interesting. All right, thank you.
Those are comments that you want to share that with the speaker?
So to share comments with the speaker, Eric Gamma is my homeboy. 20 years ago, they used to use a book called, what was it called? Fuck. Design something. That's it, yeah. Design patterns. And who was the first author? Eric Gamma, that's right, yeah. And, you know, he was like in Switzerland, and he did this domain analysis of 3 main frameworks, one of which, he did the domain analysis, it wasn't his PhD, one of which was done in, 2 of which were done in C, one of which was done in Smalltalk about how you should do display editors. And this is the secret to having a happy and successful academic life, is always keep doing the same thing from your PhD onwards. Famously, Rustin Leno has been writing the same program since he was 12. I lied, he was probably about 18 or 20 maybe when he started, and he's still doing the same thing today. And Eric Gamma did his PhD on analysis of these kind of frameworks, and then he went to a big blue company called IBM and wrote something called Eclipse, and then when he'd finished with that, he wrote Visual, is this right? I think this is right. Yeah, anyway.
All right, I have one more question. This is really cool, and I think it's. I mean, it makes a lot of sense to start with this, both because it's a nice visual. There's a visual aspect to this, to lifetimes, and because, as you showed, they're like, you know, high. Even though they're a small percentage of errors, I was surprised at how small they were. They took 10 times the average amount. I'm wondering, are there other errors that you're looking at in Rust or anywhere really that kind of fall into this category of being, you know, hard but also possibly amenable to visualization?
I think this kind of method can apply to errors with a kind of live timeline, and like there are some concept that has start or end points that that can be easily visualized, and but currently we're just looking at lifetime errors, but I think there will be some other types of errors that can also be visualized in this way. Yeah, that's an interesting future work direction.
Yeah, thank you.
So we have a follow-up project which Molly is working on to get a much sort of deeper and broader analysis of errors that people experience in Rust. So, you know, this is done in the context of a course. We're looking at deploying this sort of out in the world, and then doing a bunch of analysis of, you know, statistics of the errors that people produce, and okay, which ones are worth addressing and how can we address those. But the idea is to sort of prioritize which ones we work on according to the ones that people really spend time on. Did you want to say anything?
Yeah, so during the study, we actually found that, in fact, the most common was undefined references. So, and this was across like, also in other studies from Java and C. And we were also interested in if that's like a byproduct of the coding experience. Like if you're defining, if it's like a legitimate error, like you've mistakenly like forgot to define something and now you're trying to reference it, or if it's like just a part of like making, if errors are used as like a task list. And then kind of an extension onto this is we wanted to actually integrate the error recording and error logging with the extension so that users that are currently using Revis can actually opt into our study, and then we can get error data from all different contexts, not just our course at UCSD. And so hopefully we can get more information there, and also even use this to host other like Rust tools and get feedback on those. And so it's kind of like the start of a really big project.
Great, thank you. All right, yes, we should wrap up. So let's thank Rochen again. And now there is a break for the next 27 minutes. Come back and hear about the goals of the Luau type system 2 years on. That should be really fun, as well as a discussion, which is often one of the most fun parts of Hatra.
Yeah, Will, I was also... No, it's okay. I'm sorry that I...
Alan, Alan, can you hear me?
There. Yes, I can hear you.
Excellent. We'll give just a minute for people to filter in from the break, and then we can get started.
Cool. Oh, that's interesting. We have a horrible echo.
Oh, there's an echo?
Yeah, I'm hearing like with about a 1 second delay. So I'm guessing that is the YouTube stream.
Let me turn off the microphone here and say something after I turn off the microphone. Or okay, fine, good. No. He can't see us, can he? Can you tell him? Okay.
Yeah, I'm going to see if my headphones are going to help that. All right, could somebody try saying something?
Hello? How is this? Is this echoey?
Yeah, it's still echoing. So I think there must be something like the YouTube stream that is audible at your end that's being picked up by the microphone at your end. It's about a 1 second delay.
So Alan, the plan is we're just going to mute the mic when no one's using it, so that way you don't have to hear an echo, and we'll just turn it on when people are talking into it, okay?
All right.
Right, so let's go ahead and get started. Everyone, welcome back to the final session of HATRA. I'm now officially the chair. Will Creighton, nice to meet you all. And we have one talk in this session, which is the goals of the Luau type system. This is our a follow-on paper to some of the earliest work at HATRA. And then following this, there will be a discussion about many of the things you saw here today. So if you'd like to participate in a small group discussion about all kinds of human aspects of types and reasoning assistance, please hang around for that. And otherwise, Alan, take it away.
Cool. All right, thanks, Will. All right, so as you can see from the title, this is a follow-on paper to the goals of the Luau type system paper that we had at ATRA 2021. And I am still actually hearing echo. I am going to have to just like plow through that. But if you hear me stumbling, it's because I am hearing my own voice repeated in my head about a second or two after I say it, which is quite distracting. Right, okay. So the structure
Alan,
for this talk.
Alan, maybe just for the talk, you could just like take your headphones off and mute everything and take no sound out of the stream, and that
All
way
right,
you won't
okay.
be bothered. We are not going to interrupt
Here
you.
I am taking my headphones off. Oh, okay. Uh, let's try.
Hello, Alan, can you hear us? Thumbs up if you can hear us in the video. Sorry, so the reason why we're full alert is we can't hear you. You went muted somehow. So it's important at least that we hear you, even if you cannot hear us. So just keep talking and we'll let you know when we hear you.
Alan, say something.
Maybe, Alan, do you want to try and disconnect from the Discord and rejoin? Optimistically?
All right, ABC123. Can you hear me this time?
Yes, we can.
Right, okay. And can you see my slides?
Yes.
Right, okay. I'll start again from the top. Right. Hello, everybody. Welcome to a follow-up talk from the Goals Blue Type System position paper that we had at 2021. And so I'm going to do a recap of what was in that talk. So that's going to be probably about half the material. Is for people who weren't here 2 years ago. And what did we say then? And then there's a couple of things that I'm going to report on of like what we've done about implementing the goals that we had there. The goals have basically not changed, but we have a bit more of an idea about what we're doing in order to implement those goals. So in particular, I'm going to talk about the way that we're using semantic subtyping, like why are we using semantic subtyping, because that's not an obvious topic for a talk in the human aspect workshop. And the other progress report I'll say is we have refined the way that we are thinking about gradual typing. So even though gradual typing is like a well-worn topic, there's probably 20 years worth of work on gradual typing, we are taking a slightly different view of this than you'll find in most literature. So, and then after that, we'll have I'll say a bit about like other stuff we've got coming down the pipeline, and then like Q&A. Right. Okay. So, 2 years ago, we had a position paper about what the goals of the lower type system is. So, I can hardly encourage reading that paper and going and watching a 2-year-old video. Right. So the first thing is, why on earth are we doing like why is Roblox in the programming languages business? Right. Well, you might be under the impression that Roblox is a games company, but we're not. Okay. So if you're going to come away with one slide worth of information out of this talk, this is that slide. We are not a games company. Okay. Right. So what actually are we? So we are a platform company. So we provide the technical infrastructure that other creators use in order to create virtual experiences. And the majority of those virtual experiences are multiplayer games. So a lot of people use Roblox in order to create games. But like I said, we are not the games company, we're the infrastructure company. And so what this looks like is like we have a rough dividing line about what we expect robots to provide versus what we expect the creators to provide. It's not completely like cast in stone, but this is roughly it. Is that the creators get to do anything fun. So we think, is this an amusing thing to do? So like, are you doing storytelling? Are you creating art assets? Are you providing music? Are you like looking at gameplay? Right, all of that is fun. So we expect that the creators are doing it. Whereas if it's boring, so like implementing a physics engine or implementing a rendering pipeline or blah 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 blah. So there's a lot of stuff that is dull that goes into creating multiplayer games. And the idea is that Roblox does that. And you'll notice somewhere down in the middle of that list there's programmability. Okay, so one of the things that Roblox provides is the scripting environment that is used by creators when they discover any kind of interactivity that isn't just baked into the physics engine. They will have to actually write some scripting for it, right? And that scripting is written using the Lua programming language, and that is why Roblox is in the programming languages business. Right, so we are providing this scripting environment for creators on Roblox. And the profile of what these creators look like is drastically different than the creator profile for most programming language environments. In particular, we are serving a remarkably heterogeneous creator community. So this diagram comes out of our annual report. I heartily recommend, if you're working for a company, going and reading the annual report, because you discover useful pieces of information like this. All right, and the first thing to notice about it is how absolutely insane the numbers are on this chart. So, if you look at like the amount of money that is being handed out to creators, then there's about 4 million creators, and that's active creators. That's like in the last year, how many people actually created a game on Roblox, and there's 4 million of them did it for fun. So they are almost certainly kids mucking around with their friends. You know, they discovered from, you know, the sibling of one of their friends that they created an obstacle course in Roblox, and they were like, "Oh, I'll try that." And so they put an obstacle course together. They play around doing it with their friends. They have a fun time. You know, I've done this. I got about half an hour's worth of entertainment from hanging around with people on it's raining bombs. That was the game that I created. So, you know, it's fun doing this. Right. And that's 4 million people did that. Right. And then you look at the other end of that chart, and you can see there's 8 creators where the amount of money that they receive is measured in tens of millions of dollars. Right. And so that is like, A, those numbers are very big, and B, those numbers vary insanely. So you get very different numbers out of looking at Roblox, depending what you measure, because there are 2 perfectly sensible units of measurement, one of which is dollars and one of which is numbers of people. And if you measure in terms of income, then there is a very small number of very professional studios creating experiences. So, and you can see like there's 456 creators where their experience playing time is measured in tens of millions of hours. So like top game is I think it's about 1 billion hours. Right, okay. So this is very important, and it's very important because it's what brings people to Roblox. So a lot of people start interacting with Roblox because there are rich interactive experiences they can take part in. And those, on the whole, are produced by a small number of professional studios. That's one way of measuring what's going on with robots. The other way of measuring what's going on with robots is the number of creators, right? And now that gets you a very different picture, where there's millions of creators, and on the whole, they're not professionals, and on the whole, they skew young. So if you think, if I was recommending to a 14-year-old who's kind of interested in learning programming, how would they go about doing it? One of the perfectly sensible choices is robots. So we are not the only starting programming environment, but we are a perfectly sensible choice for beginning environments. So we have hundreds of code camps that teach people how to program using robots. And both of these measurements are important. So both the revenue measurement and the number of people measurement are important. So one of these is the kind of life and blood of the company and brings people in and provides high quality experiences. And another one provides, people getting started on programming for the first time and, bringing enthusiasm and excitement to the platform. So both of those ways of approaching programming are very important. Right, okay. And they, funnily enough, have very different goals. So if you're a professional developer, right, go and read the huge literature about how to provide tools for code quality. So, this is exactly what your traditional type system is about. Is about giving you mechanisms for ensuring code quality goals for your program. Right. Whereas your beginning creators have very different goals that they're wanting to have satisfied. So at the point where they discover they need to do some scripting, it's because they've hit a problem in their experience that they cannot solve just using the physics engine. Right? So they've discovered something like the player steps on the bridge and the booby trap goes off and the bridge collapses. Right, okay, that, funnily enough, is not built into the physics system. You have to write a script for it, and there will be some immediate goal like that they have in mind when they start using scripting. They are not, on the whole, interested in learning programming, and they are not, on the whole, interested in code quality. So they have a very different connection of goals compared to the professionals. Oh yeah, and it's not completely black and white. There is a sliding scale here. Beginners, a small percentage of those beginners go on to become professionals. Right. Now, the thing that both of these communities have in common is that, on the whole, they don't care about type errors. So, why would they want a type system in their development environment? And it's not because of script analysis. So even for the people who are professional enough to be using the code quality tools, only about 10% of them switch on error reporting. So 90% of them just ignore anything to do with type errors. So given that that's the case, why on earth do we do type checking? Right, and the reason is there's lots of other tools that are type directed, not just your kind of traditional type error reporting. So things like autocomplete and API documentation and go-to declaration, yada, 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 right? All of that is driven by the type system. And both communities are interested in that. So everybody wants good autocomplete. Right, okay. So we've got this very heterogeneous creator community. Right, the way that for us that impacts the technical development of the type system is that, okay, everything here is undecidable. So in particular, predicting whether a runtime error will happen or not. That's an undecidable problem. Right, so you have to make a decision of, are you going to go for a system with no false positives or a system with no false negatives? So are you going to go for a sound system or a complete system? Right, and there's a huge amount of literature on sound systems. Right, there is some literature on complete systems. So things like incorrectness logic and the elixir system, but they're not as common in the programming languages community. Right, whereas Lua has taken the position we want to support both of these. So we've got a mode. When you opt into type checking, you decide, do you want to be in strict mode or non-strict mode? And those have, one of those is intended to be sound, and one of them is intended to be complete. So on the whole, we try to minimize the number of false positives in non-strict mode and the number of false negatives in strict mode. Right, okay, so back to what we said 2 years ago, and what we've done since then. Right, okay, so first of all, we've done semantic subtyping. So semantic subtyping is subtyping the way you think it should work. So types or sets of values, subtyping is subset inclusion. It's like, but that's kind of like obviously like what type systems are. Right, okay. That's not quite as simple as you might think. So if you go and read the gentle introduction to semantic subtyping, you will discover that you quickly get into quite nasty issues about type normalization. So there is quite a lot of work to implement that goal of types or sets of values and subtyping and subset inclusion. Right. Now, the reason why we're interested in this is that people quite naturally have an idea this is what types are. And so if you do syntactically driven subtyping, you end up with false positives that you kind of like look at a program that it's got some horrible mess of overloaded functions, union types, possibly intersection types, blah, 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 blah. Right, and you discover that in fact you've got a false positive that's being reported by syntactically driven subtyping. And like I said, you want to minimize the number of false positives because that's like a bad experience, bad user experience. Right. So the way we've implemented this is first of all, we do actually try syntactic subtyping. Like we do the thing that you would get if you just open tuple or whatever. And if that works, yay! You know, it is sound. So if syntactic subtyping does the right thing, then we don't need to do anything clever. But if it fails, we can't just immediately report a type error. Because that might be a false positive. And so what we do is we do type normalization. Right, and this has a potential exponential blow up because that takes your the types you've inferred and converts them into conjunctive normal form. And now you run syntactic subtyping, and on normalized types, syntactic subtyping and semantic subtyping coincide. And my goodness, there's lots of devil details. So like that I've just like put one line there saying do type normalization. Right. Imagine lots of horror show stuff happens there. Right, okay. So that's one thing we've done is semantic subtyping. The other thing we've done is a bit of progress on gradual typing. And so the kind of like off-the-shelf version of gradual types uses compatible typing. So you add in your any type that stands in for anything. And the idea is that you're not going to report type errors about uses of that any type. Right. Now you define a compatibility relation between types, and in particular, everything it's compatible with anything. And now you use compatible typing everywhere that you would use type quality. So this is the version with type quality. There's an equivalent version for subtyping. So if you know, if you've got some function application and the function's got type F and the argument's got type T and F is compatible with TTU, then the function application's got type U. Right. Now the problem with that we've hit with compatible typing is that, my goodness, this is a story of very subtle bugs. So we got this wrong quite regularly because that compatibility relation isn't transitive. And so it's very easy to forget when you're doing transitive subtyping versus when you're doing non-transitive compatible subtyping. And so we got this wrong quite regularly. Right, so what we now do is, okay, if you remember like a few sentences ago, I was saying that you don't report errors when you've used the any type. Right, that's actually what we do now. So we now think of gradual typing, at least the way we do it. We think of that as being talked about error suppression. So when is it given a failure of type checking, when do you actually report that as a type error? And so what we do is we've got an infallible type system where, given any typing context at any term, we will calculate a type for it, and no matter what it is, right? And then we have a separate judgment that says when should we report an error. And the really important thing about when we do error reporting is we have a notion of error suppressing type, and in particular, any is error suppressing. And so for those error suppressing types, we actually don't report a warning. And so we now have a distinction between what programs have a correct type. For us now, that's everything. Everything actually has a type. And when is it we suppress errors? And in particular, there's a couple of things we do on that. One of which is not the relationship between non-strict and strict mode is going to be just about when do you do error suppression. The other thing we do with this is we suppress cascading errors. So if you've got a program that's got a type error in it, and then that type error causes subsequent type errors, we do our best to use error suppression to remove the subsequent errors. Right. And one thing that's slightly funny about this is that you can think of this, because we're looking at type errors as being an important object, we actually can treat those constructively. So we actually do have a constructive statement about when do you have an error. So if you look at the AGDA formalization for all of this, then we actually do have an explicit constructive notion of when a type warning happens. Right. And slightly oddly, because of, you can look at this as both being a proof and being a program. When you actually run this as a program, it turns into, you run the program, it produces a type, and then you can do time travel debugging, and you can run it backwards in time and find the root cause of what happened. And we can do that in the AGDA because we're keeping enough time information around in order to be able to do that time travel debugging. I would really like it if we could have a node where the real thing actually does that, and it's not just the AGDA code. Right, okay. And then we have some owls to draw, so we still have, I gave you the rough idea about what non-strict mode is, but we need to nail that down more precisely, and we need to treat the difference between strict mode and non-strict mode just as about error suppression. Oh, and we actually do have to ship the thing, so to put it in front of users. Right, thanks.
right, thank you, Alan, for the great talk. Now we have some time for questions. And just as a reminder, please say your name and affiliation before asking the question. So, open it up to the room.
Hi, Michael Koblenz, UC San Diego. Thanks for the talk. You mentioned that you're planning on shipping soon, but it also sounds like you have a lot of iteration involved, or you had a lot of iteration involved in the design. So I'm wondering if you could talk about kind of the iterative process that you used for design, or what design techniques you used. Maybe this is sort of repeating Jonathan's question.
Yeah, so the way that Roblox approaches that kind of iteration is that we have a beta feature shipping process where what we do is the vast majority of users of the development tools will not actually see any change. But if you want to live on the edge, then you can opt into this beta feature, and then you will get whatever the current state of how we are shipping the changes that we're making to type inference and strict mode and non-strict mode. We are trying our best not to break people into that beta feature, but we are giving slightly weaker guarantees about that than we do for people who've not opted in, because the assumption is if you've opted in, then you're prepared to live on the edge. And so that's the process that we're going to go through for getting this in front of people.
All right.
Hi, this is Cyrus Omar, University of Michigan. So it seems like there's like a hint of motivation here around type error debugging as a user-facing feature. Is that correct, or is there something that you're working on there, or what are the
Certainly
metrics at the end of
something
the
we've
day that
talked
determine what you're doing is correct?
Yeah, so that's sort of something that we've talked about. As with all software, you end up shipping your org chart, and we have like the team that looks after the programming language, and then a separate team that looks after the UX and UI for the IDE. And so, if what we want to do is just like produce type error messages in front of people, we could do that just in our team, right? But anytime we want to do anything interactive, there is an entire process of like we now need two teams to get to agree that this is a priority, and so it is trickier for us to get interactive tooling around type error debugging than it is just to do traditional here's a string, deal with it type errors. So we have discussed this, and we have discussed this as a cross-team project, and everybody has agreed this would be cool. But you can imagine that there is a reasonable amount of effort to go from a multi-team project where you've all said, yes, we think this is cool, to the feature shipping.
Got it, thanks. Other questions? I have one. This is Will Creighton from Brown. I'm going to ask, we gotta talk about the elephant in the room, which is there's a new metaverse language on the block, and it's got a lot of fans, a lot of hype. It's verse, and but genuinely, it's clearly targeting presumably a similar niche but of Luau, but from Unreal or Epic or whatever. And I'm curious if you've looked at their materials and how you would contrast both the design of the language and their goals with how you think about Luau.
Okay, so I'll preface my answer with, yes, we have looked at it, and yes, I have opinions, but, my opinions are approximately as valid as anybody else in the room's opinions, because, this is not our product. But, right, so I will give you the kind of like the brief version of this, which is there are a couple of differences between the goals that Luau has and the goals that Verus has. And part of that is that, as you might have noticed, like we have given a couple of talks now over 2 years, like at a human aspects workshop. So that for us is something that's very important. And the other thing is that we've taken quite seriously is what the experience for beginning programmers is like. Where it's diverse, like has all kinds of cool stuff there. I mean, like, they're really good people. They're really smart. They've done like technically an incredibly good bit of work of software transactional memory and explicit effect tracking. So to tame down the kind of like the non-determinism that would otherwise be part of doing a functional logic programming. So this is all really cool. That's not aimed at beginners. Like the fact that you have to like explicitly out annotate every function you write with its effect, that means that you're targeting the professional developers. So the fact that we think of them there as being like this heterogeneous development community, and that both of these communities are important, that I would say is something I would highlight as a difference between what we're doing and what Verse is doing.
All right, a very measured response. Thank you. Other questions?
I try my best.
Anything else? All right, well then we'll wrap up. One more round of applause for Alan. Thank you. I'll keep this with me. Now we enter the discussion phase. All right. Well, actually, I'll put this here and move up. So the way that this is going to work, or that we're planning on making it work, we have a sizable enough crowd for discussion. We're not going to do a whole room discussion until the very end, because that's the least productive way to use like 30 people's time. Instead, what we're going to do, or a tentative plan, is we're going to break out into small groups based on people's interests. As a coming up there, perfect. And then displays. So I have a set of topics that, based on all the things we've talked about today, I think will be interesting for us to discuss. I put that up here. Let me full screen that. All right. And so I think two particularly interesting questions, personally, that have recurred. One is, help. How do I run a user study? I think there is a lot of sense of people who have built tools, but then they're not sure of like, how do I go about the process from the high-level research questions to the low level of recruiting participants, actually make this a reality? And I think that could be a really interesting discussion. As well as another discussion is the IDE of the future. What do we want out of an IDE? What do we want to put into it? What are the limitations of things? What sort of 2D graphics libraries would facilitate all this kind of research? So these are two questions. And so I think the way this is going to go is we'll like separate out into groups. You can pick which one of these you want to talk about. We will then just chat. You will have at least one person assigned to take notes, and at the end, that person will come and summarize the findings of the group, and the more actionable those findings, the more exciting this discussion will be. Hopefully it's enlightening nonetheless. Before we split off into groups, I want to quickly check. Are there other topics from today or from the hatrosphere more generally that people want to put on this list? It doesn't just have to be these two. These are just to get us started. So, would anyone like to volunteer any additional points of discussion? We have a lot of people, so it's not an issue if we break off into more fragments. I have encapsulated the entirety of people's interests. Yes! I'm good at this. So what we're going to do then, this room is conveniently bifurcated. So let's just, let me get an initial, let me get an initial sense of interest. That's fine. We'll just run with this. So if you want to talk about, help, how do I run a user study? Go to this side of the room, stage right. And if you want to talk about the idea of the future, come to this side of the room. But everybody like get up, stand up, come to the front. And then we can like kind of arrange the chairs a little bit in a circle. Sorry, Cyrus. So people can like talk to, or maybe like, I think we want to shoot for groups of probably 5 to 7 as a productive unit of conversation. So this side is you want to talk about user studies. This side is you want to talk about IDEs. Form groups of chair circles of 5 to 7. You could do it, go. And then if you are on Discord, how many people are on Discord? Who's on the stage? I believe that's just Alan. So Alan, if you want to throw in angry comments from the back, I will simply just read them aloud as soon as you say them during any point of the discussion. I'll just be your mouthpiece. You can message me directly. Yes? That sounds great. Let me know when you're off. Remember, IDs on this side, user studies on this side.
Yeah, are they supposed to be 2 circles per side or 1? What's the constraint?
Oh, no, yeah. Keep circles small. All right, everybody, let's bring it back. That is the end of the small group discussion time, but you're still talking. You're talking even louder. All right, everybody, come on. Yes. So, once again, the format is one person from each group gets 3 to 4 minutes to share something interesting, and I will take notes while this is happening so we can record it for posterity in addition to all the notes that all of you took. So, and we'll pass the mic around. Please speak into the mic because we still have participants who are listening. We'll start with this group because you're closest. Who's speaking?
Technically, they're the closest when you're over. So we had sort of 2 sub-discussions in the time period. The first is sort of like capturing intent of what people are doing. We kind of talked about Git commits and how, you know, somebody might commit 10 times with the same message of like IDK or this might work now. But really it had an overall intent between all those changes, and how can sort of our environments more easily reflect that and capture the intent that we have. You know, diffing programs, collaboration between people, etc. The second thing that we talked about is kind of the fundamental conflict between what we want for a specific task, for a specific language, versus what, you know, somebody might use in industry, which is more domain general. And as HCI, you know, PL researchers, what are, this is the fundamental question of like, how do we want to view IDEs and how do we want to do research on them? We didn't really come to a good conclusion, but the thing that we did talk about a lot was domain specificity of how we can enable certain tasks and.
Give me one good example of a feature that elicits that tension.
Like a live programming environment called Hazel, which is used for students at the University of Michigan.
Right, but what is it?
Yeah.
What is it about the Hazel IDE that sort of is specific to Hazel and would be difficult to argue that this should be part of a general purpose IDE?
So the thing that we had talked about is narrative, like being able to capture the intent and narrative between like what you're trying to express.
Okay.
Yeah, please.
Yeah, please. 10 seconds. I mean, like one specific example would be not any popular programming language has an effect system. So you can't just like run things all the time live on every keystroke.
Okay.
Okay, we talked about a lot of different trade-offs. You know, so like for example, there are language servers, and it's very convenient, but then the language servers don't convey the right information to the IDEs, and so there's a question of like how to design that interface so it scales better, but also you want it to be simple, so it should be more usable. We talked about kind of some issues around liveness. So you know, in Coq, the IDE will rerun your code when you make a change, but then it can take a long time for it to rerun the code. But then there are other systems like you know, Jupyter Notebook, where it's not live and then things get stale. And so it seems like either way you lose somehow. So it's another trade-off that's not clear how to make that trade-off. We talked a bunch about kind of files and the problems with files, and IDEs are organized around files. But you know, do you really want to be choosing which files each code element goes in, and what is the order of your methods in a file, and does that really matter? And should it be more like a database or more like Smalltalk? How should we think about that? We talked about version tracking. So these version tracking tools work great sometimes, maybe with textual-based code, but then when you don't have text, it's a problem. So you know, how would you diff sequences of outputs of programs? You know, like you have an interactive app, and then you click here and you type this, and then something happens, and then you change the code, and now you have a different sequence of outputs. So how do you diff those outputs? How do you diff, you know, Illustrator files or Oopsla talks, which are slides? Not clear how to diff those, but you know, it seems like those, you know, if you want to integrate more kinds of things as code, then we need to figure out how to version control them appropriately. We also talked about sort of this trade-off of sort of the Eclipse style of IDEs, where everything's very open and you can change all kinds of things, but then changing anything in particular can be very hard, and also it can be very unstable. whereas in VS Code it's very closed, very constrained. It's very safe and reliable, but then certain things that need to happen to make your IDE do what you want, you just can't do. Let's see, and finally, I propose that if you want, we talked about visualizing co-inductive things.
Random question there.
Yes.
Since no one uses Eclipse anymore, does anyone remember what actually is bad when everything is changeable? Are there good documented instances of things where plugins conflict or destroy your IDE or whatever? Does anyone have a good example?
I see some nodding over there. Do you want to see?
Yeah, so a bunch of plugins will make it really slow, and some will
Performance. I see.
You have plenty of examples.
Yeah. Got it. Okay, so performance as well as mutual incompatibilities.
My experience is there are 5 million extension points, and you can't figure out which one you want to use.
And we were using it in teaching, and every year we would need to find new plugins because Eclipse would release every year.
Oh no.
Release once every 10 years.
I see. New releases of Eclipse are incompatible with old plugins. Yeah.
There, the problem you have is that you have one extension point that two extensions are using, and they don't know how to use it, and so they conflict. So for example, you'll have something that displays type annotations in your code, and something else that displays highlights of where you have errors. And the type annotation thing, when it wants to update annotations, will clear all annotations, including the error underlines, and displays those things. It's
Right. Talking about the incompatible use of extension points in Emacs. Great. All right, thank you. Also to emphasize, I love concrete examples, as you can tell, so keep them coming. These are great ways to back up the general statements that we're listing. Anyways, continue. Anything else, Michael?
And then finally, we solved the problem of visualizing co-inductive traits in Rust. In order to visualize co-inductive traits in Rust, you just visualize co-inductive traits in Rust better, and then it's all done. That's all.
Okay, so first our group discussed how text is bad. The concrete examples of this were, we talked about code bubbles, I guess, which is another interface for representing code that's not limited to sort of the files text Unix philosophy. But then we said, oh, actually, visual bad. Two systems that we mentioned were Isabelle and NewPerl, and how it's hard to read programs written in those languages on systems that don't have support for viewing their particular file formats, and diffing non-text formats.
I have not used either system. Are they not plain text? They have some sort of structured format you have to use?
Yeah, sure. So NewPerl's development was originally funded on a database grant. And so the system, by default, stores everything in a database. And so, at least when it was taught to me, close to 7 or 8 years ago, was well, how do you do diffs, or how do you go back to a previous version? And the answer is, oh, you send an email to the database administrator, and they'll just get the old version for you.
Oh, God.
It also only runs on one machine at Cornell, right?
Yeah, then we started talking about we started thinking about a little bit sort of some reasons for why this might be the case, and we mentioned the viscosity problem that Cyrus had introduced earlier, and I think sort of got to thinking how the viscosity problem might appear in some of these other cases, both in structure editors, but maybe in sort of code bubbles or other types of graphic representations of code. I guess internally, I was thinking also about notebooks as an interesting example of viscosity. Let's see, then we discussed input paradigms as another version of this problem. So even in IDEs that have structure editors like paredit, people still enjoy writing directly in text in addition to doing structure edits. Then we switched. These other points have some more overlap, I think, with the other groups. So we started talking a little bit about VS Code, about how VS Code is sort of centralizing work and whether that's good or bad and what aspects are good or bad. So very similar things like LSP being a useful thing, but also constraining as being the only thing.
I can't read my own handwriting. The school. Right, and then we had our own small talk discussion. Well, which I think is interesting because so then we're talking about like, oh, like you can embed visual notation inside of a text editor, and so this sort of brought us full circle to think about, so why do we think embedding visual notation in a text editor is useful when having these visual layouts of code is not so useful?
Yeah.
And I'm not really sure we came to a big conclusion on that, other than like it's sort of interesting to think about, and maybe it goes back to this whole text thing where when you're embedding visual notations inside of text, you're still in sort of a text-centric world versus these other representations.
I love it. So I think if I had to summarize the ID discussion, I think the most salient point is like the plain text IDE of just there's a text box and you edit it as like the basic unit is where we start. And we would like to enhance it sort of with more visual representations, either of the code itself or of metadata about the code, like diagnostics and so on. But those extra enhancements come with all of these issues, such as whether they compose together well at extension points, or whether visual representations are superior to text, either inherently when manipulating them, or when dealing with like diffs or something like that. So I think it's good for us to think about, right, when we try to create, like, what are effective visual representations of programs and metadata about programs, but also from a system design perspective, what does it mean to make these things as compositional as possible, right? It's the system design level question no one's really tackled. That's my summary. All right, moving on. Let's pass it to our one user study group. You get the first and final word.
First and final word.
Yes.
Okay, two quick notes. First, Cyrus did not invent viscosity. It's cognitive notations. Just one. Number two, we did not talk about small talk at this group, so.
It's been placed in the record.
We talked about the idea behind this is help user studies. So we had a few questions that people came up with. The first question, which I thought was very interesting, which was just, is this really realistic to talk about doing user studies of programming tools because they're so different than, every tool is very different from the next. The concrete example, for Will's sake, that was brought up was the cock mode in Emacs. That includes a lot of features. There's a lot of things going on. If I want to demonstrate, though, that it was better than using cock with the cock mode in Emacs is better than using cock without it, it would be very challenging because there's a lot of things that are different. And it takes a long time to learn how to use it effectively, et cetera. So how can you do anything at all in an hour? And so we talked a lot about techniques for carving out the specific thing you're interested in studying, as opposed to this tool as a qua-tool. You think about what is the specific general principle that's embedded in cock mode and Emacs that you want to study, that you're interested in evaluating, and you think about how to design a study that compares exactly that against whatever people are doing already. This guy named Will talked a lot about survey design and languages. I don't know what he was talking about. Then we had a long discussion about like how much data to collect in studies. You can collect basically an unlimited amount of data we have the power to collect basically an unlimited amount of data when we're studying programmers because we can collect every keystroke, we can monitor every single thing, but then you get all this data, and what do you do with it? And so we talked about like what is exactly the right thing, and then we specifically talked about ways we might be able to assess experience and skill in programming more systematically, and the idea of having a more standard set of questions that we can ask, that every study can ask about experience that's validated and that could be used from study to study and more easily compared.
I love it. Yeah, and in general, more validated metrics. I cannot emphasize enough how valuable it is when people say like, here's a lightweight tool you can use and here's a study you can cite that shows that this tool is a good idea when evaluating, I don't know, someone's experience as a programmer or what have you. I think it's a very cool idea, and there's not enough of that in human factors research. All right, well, we are exactly at 5:30, my God. So we've reached the end of HATRA. First of all, thank you so much to Michael for being the principal organizer, and to all the organizers, co-chairs, and program committee. Big round of applause for them. And an equal round of applause to our student volunteers and IT staff who made this whole thing come together. And lastly, to all of you, thank you for attending, and here's your to-do list. Get started.
Doing